ఈ జాయినింగ్ ఏ మినిట్ అండి.
ఓకే సార్.
ఓకే సార్.
డిఎన్ రావు గారు అక్కడికి వచ్చారా లేకపోతే ఆన్లైన్లో జాయిన్ అవుతున్నారు?
సార్కి మీటింగ్ ఉందండి సార్.
ఆయన రావట్లేదా?
సెక్రటరీ గారు కూడా బిజీగా ఉన్నారు సార్. సార్
గుప్తా, గుడ్ మార్నింగ్.
Good morning.
Sir, good morning, sir. Good morning, all.
Good morning, everyone.
ఈ కన్నాల్ వెంకట్ జాయిన్ అవుతున్నాడా?
అదే కాంటాక్ట్, ఐ థింక్ శివరాజ్ ఈజ్ కాంటాక్టింగ్.
మూర్తి గారు గుడ్ మార్నింగ్. శుభానందరావు.
వరవీణా మృదుపాని వనరుగలోచనురాని సురుచిరబంబరవేణి సురనుత కళ్యాణి వరవీణా మృదుపాని వనరుహలోచనురాని సురుచిరబంబరవేణి సురనుత కళ్యాణి నిరుపమ శుభ గుణలోల నిరత జయా ప్రదశీల వరదా ప్రియ రంగనాయకి వాంఛిత ఫలదాయకి సరసీజా సను జననీ జయ 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 కళ్యాణి. Thank you.
Yeah, your mic is in mute.
Thank you so much, Neha. We feel blessed indeed. So let's move forward. Now I consider it a great honor to request Dr. Shivraj Narayan Yole Garu, our Organizing Secretary, Sdme 2020, to deliver the welcome address.
Thank you, Deepshika. Respected Dr. D.N. Rao Sir, President, Vignan Jyoti. Sri K. Harishchandra Prasad Sir, General Secretary, Vignan Jyoti. Chief guest of today's inaugural function, Sri K.P.S. Murthy Sir, Director, High Energy Materials Research Laboratory, Pune. Guests of honor of today's inaugural function, Dr. Manoj Gupta, Professor Mechanical Engineering from National University of Singapore, and Colonel Venkat, Director, Faculty Development, AIST New Delhi. Our beloved Principal, Dr. C.D. Naidu Sir, Dr. Chenna Keshavarao Sir, Director for Advancement and Dean Administration, Dr. Subhanand Rao Sir, Director R&D, Dr. G. Srinivas Gupta Sir, Convener of Sdme 2020 and HOD of Mechanical Engineering. Distinguished delegates, participants, my dear colleagues, students, ladies and gentlemen, a very good morning and warm welcome to the inaugural function of the AIST-sponsored two-day international conference on sustainable development in mechanical engineering organized by the Department of Mechanical Engineering during October 30th and 31st, 2020. As an organizing secretary, it is my pleasure to present before you the preface of this e-conference. This edition of the e-conference is indeed a special one for two reasons. First, that it is being conducted as part of the Silver Jubilee celebrations of the Institute, and second, it is being conducted online for the first time in the department, that too due to the prevailing COVID-19 pandemic across the globe. In fact, originally the conference was scheduled to be held in March 2020, but because of the lockdown and other reasons, it had to be deferred. The theme of e-conference is on sustainable development in mechanical engineering. Sustainable development is an idea that human societies must live and meet their needs without compromising the ability of future generations to meet their own needs. With the natural resources depleting so fast and the kind of carbon monoxide emissions and pollution levels rising alarmingly, it has become the need of hour to go for developing products and solutions that are sustainable in true sense. It is expected that the developed innovative product and solutions help in reduction of waste, emissions and pollution level, thereby leading to sustainability. Technology associated with mechanical engineering need to be aimed at providing solutions to these issues. The current trends and research indicate that a lot of exploration is going on in the field of sustainability aspects in mechanical engineering. So how do we make more people, especially the student community, aware of these developments, and how the researchers and academicians become more knowledgeable about the future success factors so that they can deliver sustainable and innovative products and solutions to the society. So with these questions and objectives in mind, the Department of Mechanical Engineering planned to organize this two-day international e-conference with an intention of providing a platform to the researchers and academicians to demonstrate their sustainable solutions proposed by them through their research. We are glad that the international conference has been sponsored by AIST New Delhi. Also, the theme of conference on sustainability has been very well appreciated by the industry, which is evident from the fact that many industries came forward for sponsoring this event. To name a few, I would like to make a special mention of Lokesh Machine Tools Hyderabad, MakerBot India, iForge 3D, VSD Enterprises, Sdme Scientific Solutions Private Limited, Invoke Engineering Solutions, Cantor CAD. These industries have come forward for sponsoring the event. Right from the launch of the conference, we received a very good response from across the country. We received around 180 papers in total, out of which 120 were asked to submit the full papers after scrutiny. After thorough peer review of these papers, we have around 52 papers for final presentation, and these presentations are scheduled in a total of 8 sessions, which would be conducted in online mode through Google Meet platform. The sessions are divided into mainly 4 presentation tracks: sustainable design, sustainable manufacturing technologies, sustainable materials, and sustainable thermal and fluidics. Apart from these presentations, we have 4 invited keynote lectures lined up for our audience. Dr. Manoj Gupta sir, a renowned academician and researcher from National University of Singapore, who is also the guest of honor of today's inaugural function, would be delivering his keynote on the application of sustainable magnesium in engineering and biomedical sector. Then we have Dr. Sivaram Krishna from Usmania University, Hyderabad, who would be talking about the sustainability aspects in 3D printing through case studies. On the second day, we have 2 more keynote lectures. One is from Dr. Netaji Kesana, who is senior scientist from Institute of Energy, Norway. He will be talking about the design studies, challenges, approaches, and the various case studies in production and processing facilities. And the last keynote lecture would be from Dr. M. Ravi Sankar, a professor from IIT Tirupati. He would be talking about nano finishing of biomedical implants. The conference would culminate on the second day with the valedictory session. The valedictory session would be graced by Dr. M. Manzoor Hussain, Registrar of JNTU Hyderabad. I hope that the keynote lectures and the paper presentations would definitely provide insights into the sustainability aspects of mechanical engineering and also create interest among the budding researchers. With these words, I once again welcome you all to this two-day international e-conference. Thank you. Over to Neha.
Thank you so much, sir. Now, I invite Dr. G. Srinivasa Gupta Garu, Convener Sdme 2020 and HOD Mechanical Engineering, VNR VJIT, to address the gathering.
Good morning, you all. Our beloved principal, Dr. C.D. Naidu Garu, Honorable Chief Guest, Dr. K.P.S. Murthy, Director, HEMRL Pune, Honorable Guest of Honor, Dr. Manoj Gupta, National University of Singapore, respected Colonel Venkat, Director, AICTE, respected Dr. D. Nageswara, President, of course he may join, Vignan Jyoti, Sri K. General Secretary, Vignan Jyoti, Dr. B. Channakeswara, Director for Advancement and Dean Administration, Allurpal Nageswara, Vignan Jyoti Institute of Engineering and Technology, and Dr. A. Subbananda Rao, Director, R&D, VNR VJIT, our invited guests, ladies and gentlemen. From the Department of Mechanical Engineering, VNR VJIT, a warm welcome to you all for the inaugural session of the International E-Conference, Sdme 2020. It is my privilege and great pleasure to assert on the occasion of Silver Jubilee celebrations. The International E-Conference is being organized by the Department of Mechanical Engineering, VNR VJIT, on the theme of Sustainable Development in Mechanical Engineering, Sdme 2020. In the era of disruptive technological evolutions and industrial revolution, mechanical engineering and allied areas play a significant role in transforming traditional mode of learning into the level industry 4.0 and co-working of men and machine. In this connection, the conference is to make an attempt to focus the attention of the professionals at global level to interact and share their knowledge and expertise on sustainable developments in various mechanical engineering domains apart from traditional topics like composites, advanced materials, biomechanics, biomaterials, renewable energy sources, advanced manufacturing, green manufacturing systems, supply chain management, industrial design, artificial intelligence, Internet of Things, robotics, automation and mechatronics, automotive vehicles, so on and so on. To deliberate and find possible solutions for better living standards of nations across the globe, and also to identify key areas for further research. On this occasion, as head of the Department of Mechanical Engineering, VNR VJIT, I am happy and proud to put forth achievements of our department. Department of Mechanical Engineering, VNR VJIT, was established in the year 1995 as MBA accredited since 2008 onwards, and BTech program with an intake of 120 students. Department offers PG programs in advanced manufacturing systems and CAD/CAM specializations. Department has got recognition as research center by JNTU-H and AICT NDF, and research scholars are actively involved in research activities. Department has well experienced and dedicated faculty. More than 50% of our doctorates in diversified domains from various reputed institutes like IITs and NITs. Our faculty members published significant number of research articles in national and international journals and successfully completed 12 research projects funded by AICTE, UGC, DRDO, MSME, etc. Also, I am happy and excited to inform that our department faculty and students have 10 national and international patent publications. Currently, department has ongoing funded research projects in the areas of joining technology, composite materials, and solar desalination. Department provides laboratories with advanced state-of-the-art facilities like digital manufacturing, automation and robotics, advanced DTM, industry-oriented CNC lathe, and variable compression test rig, so etc., to inculcate the spirit of global competitiveness among the students. Department has MOUs with reputed industries, institutes, R&D organizations, and universities in India and abroad. Students' innovative ideas are also encouraged on design and development of systems or devices and motivated to participate in various national and international events and competitions such as Supra Formula Student India, Quadra Bike All-Terrain Vehicle, ASME Human Powered Vehicle Challenge, etc. Staff are also sponsored for presenting their research concepts at international conference in abroad. Our staff receive travel grants from various agencies like AICTE, UGC, etc. Faculty research interest groups are actively involved in the research areas like thermal design, automation and robotics, digital manufacturing, advanced materials, and so on. Staff offer internships at national level on their areas of expertise during summer vacation for students. Department is proud enough to mention that students are nurtured to develop as an entrepreneurs and establish startups. To mention a few, Jarsha Innovations and Solvable Technologies, and got appreciation from state and central governments for benefiting society at large. Department faculty are reviewers of indexed journals like International Journal of Acoustics and Vibrations, International Journal of Computer-Aided Engineering and Technology, Frontiers in Energy, Energy Transportation Research, Advances in Science, Technology and Engineering Systems, Journal of Industrial Engineering, etc. Our faculty are invited as resource persons in various national and international events and also members of research review committees of reputed universities and organizations. We, the Department of Mechanical Engineering of VNR VJIT, are thankful to our management, principal, and directors for their continuous support and encouragement for organizing events of this nature. I would like to extend my heartfelt thanks to All India Council of Technical Education for their support and encouragement for sponsoring various research projects, models, and faculty training programs since the inception of our department. We seek similar support and encouragement from AICTE for our future endeavors. I take this opportunity to express my heartfelt appreciations and gratitude to all the participants, others, delegates, keynote speakers, session chair. I congratulate the organizers for their efforts which have culminated in Sdme 2020. And I wish the event all success. Thank you, one and all. Thank you. Thank you. Power to this.
Thank you so much, sir. The next dignitary to honor us with his presence is Dr. Sdme Garu, Principal VNR VJIT. Please welcome, sir.
So thank you, sir. Good morning to all the members of who joined for this meeting. Respected Dr. D.N. Rao Garu, General Secretary, President Vijnana Jyoti, Dr. Harisun Prasad Garu, General Secretary Vijnana Jyoti, and today's chief guest, KPS Murthy Garu, Distinguished Scientist, MEMRL Labs Pune, and Dr. Manoj Gupta, Professor, National University Singapore, and other my colleagues and distinguished scientists, ex-scientists of DRDO, Shubhananda Rao Garu, Directors, Channakeshwara Garu, Head of the Department Gupta, and Shivraj Narayan, and other members of who organized this conference from Department of Mechanical Engineering. I congratulate the Department of Mechanical Engineering for organizing this international conference on advanced topics on sustainable materials. So is the need of the hour probably. So on this occasion, we also thank AICTE for granting us the funds for organizing this e-conference on mechanical engineering courses subjects. So coming to our institution, Vallurupalli Nageshwara Vijnan Jyoti Institute of Engineering and Technology was established in the year 1995. So this being the 25th year, slow jubilee year, so we are organizing a series of conferences, seminars, symposia across all the departments. So we also thank all the members and researchers for contributing their research papers to this conference. So this institute is an NAAC accredited institution with A++ grade and also QS international ranking is also there, and this institute is ranked at 127 in the national NIRF ranking by MHRD among the engineering colleges in the country. So other courses, all the courses have been accredited, all engineering courses have been accredited by National Board of Accreditation for all the courses being offered in this institution, undergraduate courses. So we offer 13 undergraduate courses and 13 postgraduate courses in this institute. So, and it is a UGC recognized autonomous institution. So with these few words from the institution perspective, I congratulate the Department of Mechanical Engineering and Shivraj Narayan for organizing this conference. I also thank all the chief guests of today's inaugural function, Murthy Garu, and then Manoj Gupta and keynote speakers. I thank for having all them on the board today. Thank you one and all for giving this opportunity to me. Thank you.
Thank you so much, sir. Next, we look forward for the presence of Dr. B. Channakeshwara Rao Garu, Director for Advancement and Dean Administration, VNR VJIT. Please welcome, sir.
Thank you. Namaskar to all of you. Swagatam, Suswagatam to International Conference. Respected Principal Garu, Sdme Naidu, and respected today's chief guest of the function, Murthy Garu. He is an excellent speaker in the area of materials, and he is the scientist from DRDO. And Manoj Gupta Garu, professor from Singapore. So welcome to VNR VJT, sir, but both of you. And Subhanandarao Garu, Gupta Garu, and Shivaraj Narayana Garu, and other speakers and eminent personalities who have joined for this conference, and delegates from various colleges and research institutions, and ladies and gentlemen. First of all, it gives me a great pleasure to extend warm welcome to all the guests, learned intellectuals, and delegates from various institutions who have joined virtually, because it is not possible to conduct physically during this pandemic time. That's why we have decided to conduct this conference virtually for 2 days international e-conference on sustainable development in mechanical engineering during these 2 days. In this particular situation, especially, everybody is talking about the new technologies like mezzanine technologies. I think hereafter there is no mechanical, there is no electrical, there is no electronics, computer science. So here, I think everybody is talking about only the new technologies like AI, machine learning, deep learning, IoT, then blockchain, quantum computing. So all these are all the upcoming technologies. I think unless we upgrade ourselves, I think it is very, very difficult to sustain, because even though our theme is sustainability development in mechanical engineering, but each mechanical engineering, I think they have to concentrate only on especially all these technologies, including 3D printing, that is nothing but additive manufacturing, and as well as automation, robotics, autonomous vehicle. In addition to all these three areas, I think we have to concentrate on other new technologies also. So in this 21st century, technology is advancing at a very fast rate, and there is a great demand for only new technologies or emerging technologies, or you can call it as a mezzanine technology. You know, in our VNR VJIT, we are calling it as a mezzanine technologies. So in this connection, I think each one of us, I think we have to eye open and see that how to improve our knowledge in this particular area, especially even AR, VR also, augmented reality and virtual reality also one of upcoming area in mechanical engineering. So as for this, that is a UNDP that is developed in 2015-17, that is a sustainable developmental goals. I think you're all aware about all these sustainable goals, but out of 17, I think 4 or 5 are very, very important for all of us actually. One is the how to improve the quality education. That is the quality education is the 4th goal, and 5th one is the clean water and sanitization, and next one is the affordable and clean energy. I think each one of you, I think we have to work in this particular direction, how to provide clean and safe and affordable energy to all our people, especially in this country. And next one is that is also very, very important, industry, innovation, incubation, entrepreneurship. All these are all the, I think, terms everybody is using, but so each one of you, I think we have to educate our students and our faculty also to upgrade their required skills in this particular area. Incubation, that is very, very important. Internships and startups. I think today, I think everybody is talking about how to provide the startups to this particular student community. So in this connection, I think each one of us, I think we have to work. What are the technologies that are required today? Unless we can change our curriculum, unless we teach all these new technologies, I think it is very, very difficult to sustain this mechanical engineering branch. But there are 3 key important elements which are very, very important to improve the sustainability. One is the social equity, that is very, very important. And the second one is the environmental protection. And third one is the economic viability. So all these 3 elements which are very, very important three pillars of sustainability development. So unless we have a strong foundation in mechanical engineering to deal with all these things, I think it is very, very difficult to sustain in the mechanical branch also. But I think why all these things are very, very important, because today the population is growing like anything. And the second one is the aggression. And third one is the pollution. So because of these three reasons, that's why each one of us, we have to do a lot of research work in the new materials, lightweight materials or high energy materials. So these are all the upcoming materials. I think each one of us, we have to work in this particular area and try to explore what are the various possibilities that are available so that we can reduce the cost of product, and at the same time we can reuse all the materials which are used for producing the products. And next important thing is how to reduce the pollution also, because nowadays because of excessive usage of various natural resources materials, okay, so there is a depletion of natural resources. So naturally what will happening, so we have to think about alternative sources for fuels. Okay, that is a very, very important. And the second one is the alternative sources for energy. So these are all the various areas, potential areas for doing research work in mechanical engineering. So, and next important is what is the role of mechanical engineering in sustainable development. So everybody is, I think, discussing about only how to make use of renewable energy. There is one area, I think each one of us, we have to do a lot of research work. And the second one is how to make effective usage of lightweight materials or efficient materials to tackle all these things. And next important one is sustainable manufacturing also. I think today the manufacturing sector is not at all doing well, especially you're all aware about that. But in spite of that, I think we are looking for alternative manufacturing methods to improve the efficiency of the process. So that way, I think each one of you in design area, I think everybody is working on composite materials and as well as the stress analysis and optimization of various parameters, even CFD also. And thermal and energy systems, I think we have a design optimization analysis of thermal fluid systems and micro scale fluid flow and heat transfer analysis and energy systems design and optimization. These are the three areas I think each one of us, I think we have to concentrate. Those who are interested in thermal and energy systems, and those who are interested in manufacturing processes. So sustainability manufacturing, additive manufacturing, computer-aided quality control. So these are the areas where we have to concentrate and try to acquire what are the skills that are required to implement effectively. So these are some of the thrust areas, major thrust areas in mechanical engineering. One is the design, second one is the thermal, and third one is the manufacturing. In which the fourth one is management is also equally important. Unless you practice all these principles, I think it is very, very difficult to sustain in the mechanical branch. So in this connection, I hope you are going to discuss the various issues or the challenges faced by the mechanical engineering during this particular situation, and how to improve that customers' satisfaction. That is also equally important. So please, all of you, discuss in this particular conference and come up with some solutions, because the solution is also very, very important. Cost-effective solution we have to provide, because the society is looking for the quality solutions rather than only simply providing the solution. So in this connection, I think Manoj Gupta Garu and Murthy Garu and other Venkat also is going to join shortly. So all people, I think you have to explore what are the possibilities that are there, how to improve the research in this particular area. That's why we have arranged this conference to disseminate the knowledge in the thrust areas as well as the upcoming or emerging technologies also. So I think you're going to enjoy these 2 days. I once again congratulate the Department of Mechanical Engineering under the leadership of Gupta and Sivaraj Narayana and Jay Prakash and Kiran Kumar and Ajay and all other people, whoever is associated with this conference. And also thank AICT for providing funds for organizing this conference. I wish you all good luck. Thank you. I hope you are going to enjoy these 2 days. Thank you.
Thank you so much, sir. It was indeed a very thought-provoking address. With equal pleasure, I would like to invite Dr. A. Shubhananda Rao Garu, Director R&D, VNR VJIT, to address the gathering.
Good morning, everybody. Am I audible?
Yes, sir.
Right. Mr. KPS Murthy, Chief Guest of today's conference, outstanding scientist, Director HAMRL Pune. Actually, I am the predecessor director to him, to this laboratory. I was there for 7 years, 2004 to 2011 as director of this lab. Now he is heading this lab. Dr. Manoj Gupta, Guest of Honor, Associate Professor, National University of Singapore, Principal, Director Advancement, Gupta, HOD Mechanical Engineering, Shivraj Narayan, Organizing Secretary, faculty, participant, students, ladies and gentlemen. First of all, I would like to congratulate the Department of Mechanical Engineering, who is conducting this e-conference on important topic, sustainability development in mechanical engineering, as a part of Silver Jubilee celebrations of our institute. Our institute is celebrating this year as a Silver Jubilee year, and it is very apt for the department to conduct an e-conference and also sponsored by AICTE. In the present societies of developed and even developing world, many products and processes are being developed by application of advanced technologies and disruptive technologies like 3D printing, artificial intelligence, robotics and automation, AR and VR, and many more to meet the requirement of the society and also to improve the quality of life. So when we design a product, we apply these technologies, all right, but we follow certain principles when we design a product. First of all, it should meet the requirements. It should be cheap economically, and it should be designed for quality. But these are the three normal things what we look into when you do a design of a product. But now other dimension has come. It should be designed for sustainability along with the quality. So what is the meaning of this sustainability? That is the key word ringing in the minds of all of us, the engineers. So the sustainability essentially means meeting the needs of the present without compromising the ability of future generations to meet their own needs. So we have been enjoying, and we should allow others also to enjoy in the future generations. That is the meaning of the sustainability. We have to sustain the whole world. We have to sustain for a number of years to come. So this is what is required for sustainable development, and we engineers have a greater role in this endeavor. As Dr. Channakeswar Rao said, a UNO has recognized this and set 17 goals with 169 targets. And one of them is the industry, the three I's: industry, innovation, and infrastructure. What it says, goal says, build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. This is what is the goal. And the whole world is working towards this goal as per the directions of the UNO. The sustainability, essentially, there are three P's, One is called planet, other one is the prosperity, and the third one is the people. These are the three essential criteria for achieving the sustainability. So the one is the planet, which is an environmental system, which includes the climate change, ecology, natural resources, energy, etc. And the criteria is harmonization with environment. This is the criteria. And the second P is the prosperity, that is industry and technology. And the criteria is revitalization of our economy. And third is the people, that is the human system, which includes the safety and security, education, health, lifestyle, etc. And the criteria is to improve the quality of life. So these three pillars, these three P's are essential criteria for achieving the sustainability. So for any design of any product development, design phase is a very crucial phase in any development of the product or process. So designer has to think about the life cycle of the product, not only the performance, the total life cycle of the product. The life cycle means it starts with the raw material input, raw material processing, manufacture, packaging, usage, consumption, maintenance, disposal, and recyclability. These are all the phases in the life cycle of any product. So during the design of this, all these phases of the life cycle have to be considered very carefully. what we call this life cycle cradle to grave. That is from the beginning, raw material stage to the disposal, cradle to grave. That is what the meaning of life cycle. So with reference to this life cycle, suppose if you try to define sustainability, which is the ability to sustain something for its life cycle without depleting resources, and also you should not damage the environment. There are two things. One is you should not damage the environment, and you should not lead to the depletion of the resources. So we have to have some principles of design for achieving the sustainability of development of any product or processes. One is the minimize the damage to the environment. This is the fundamental thing. And next one is minimize waste. So in quality circles, we call zero defect to ensure the quality. In sustainability circles, it is called zero waste to minimize the waste. The third one is minimum energy requirement during manufacture, its usage, its disposal. In all the three phases, the minimum energy requirement should be there. And the fourth one is benign emissions. Emissions should be less or effluent should be less. And the next one is minimum depletion of natural resources. And the last but one is the recycled inputs. The raw materials, what we use should be already recycled inputs. And the last one is the recycling during disposal. Disposal, we should not just throw away, we should be able to recycle it. These are the fundamental principles that are followed for the design for sustainability. So now sustainability, because it is so important, it has become a subject by itself, sustainable engineering. That is the subject that is being taught in all the institutions which strives to maintain sustainable principles in engineering. Some of these principles are using methods to minimize environmental damage, minimize waste, incorporating environmental and social constraints in engineering decision making, use energy and resources at a rate that doesn't compromise the natural environment. These are some of the principles that are being followed in mechanical engineering aspects of sustainability. So when we design, we have to balance the three areas for sustainability. One is called technical sustainability, other one is operational sustainability, third one is environmental sustainability. So technical sustainability means what decisions we take during the design that matters. The design decides the quality, design decides the sustainability, design decides the performance. Everything, design is the crucial phase, and whatever decisions we take during design, that matters a lot. And the next one is operational sustainability, which means the burden on humans during deployment. The operational burden, it should be less. Third one is environmental sustainability, very important. You should have very less impact on ecology and emissions. So these are the three areas which has to be balanced during the design. So for the engineers who are working in this, there are many tools available for analysis and evaluation, and information management systems are also available. And many people are working in this area of sustainability in mechanical engineering in our discipline. It is being taught in all academic institutions, and a lot of research is going on in applied areas, applied research. So that is why our department has chosen this topic, the sustainability development in mechanical engineering. And I wish these aspects will be discussed in the next few sessions, what we are going to have today and tomorrow in this conference, and mutually share the knowledge. So I wish all the success and all the best. Thank you very much.
Thank you so much, sir. Now, I find immense pleasure in introducing our Honorable Chief Guest, Dr. K.P.S. Murthy Garu, Outstanding Scientist and Director, HEMRL, Pune. Shri K.P.S. Murthy Garu assumed the charge as the Director of High Energy Materials Research Laboratory, Pune on 1st August 2015. Prior to his appointment as Director at HEMRL, he has served as Associate Director of Armament Research and Development Establishment and successfully steered the design and development of warheads and fuse projects for rockets, missiles, torpedoes, and bombs. An IIT Kharagpur alumnus, Shri Murthy started his scientific journey with ARDE and made outstanding contributions in the design and development of warhead subsystem of various missiles such as Prithvi, Akash, Nag, Air Defense, Nirbhay, etc. He was instrumental in developing many advanced warheads technologies like detonation wave aiming, deep penetration, thermobaric warheads, and high-performance shaped charges. A self-reliance evangelist, he has successfully spearheaded several talks to ordnance factories and encouraged private participation in development and production activities. In his career spanning 27 years, he has pioneered and innovated various mass preformed fragmentation concepts for developing fragmentation warheads, tandem warheads for third generation anti-tank missile system, penetration cum blast submunition warheads, fragment generator for ballistic missile defense applications, directional blast and shaped charges for underwater application, novel PCB and TB ammunition for MBT Arjun 500 kg general purpose and pre-fragmented bombs, submunition warheads for rockets, pyro-operated safety arming mechanisms, impact delay fuses for various weapon systems. He is presently steering development of advanced cutting-edge technologies via advanced tank and artillery gun propulsion systems, fuel-rich, high burn rate solid rocket propellants, processing of HD 1.1 propellants, new generation reactive armors, advanced thermobaric compositions, and modeling and simulation of explosive initiation and propellant combustion phenomena. He has published more than 30 technical papers in reputed national and international journals, seminars, and symposiums. There are 4 patents to his credit. He is the recipient of many prestigious awards, including DRDO Special Award for Strategic Contributions 2017, DRDO Agni Award for Excellence in Self-Reliance in 2014, 2009, and 2005, DRDO Award for Performance Excellence in 2016, 2014, 2012, DRDO Award for Pathbreaking Research or Outstanding Technology Development in 2008, DRDO Scientist of the Year Award in 2008, Dr. Byron Roy Trust Award AESI in 2007, DRDO Lab Level Technology Group Award in 2006. In addition, under his dynamic leadership, HEMRL has been awarded Public Sector of the Year Award 2017 by Indian Institute of Materials Management, SKCH Order of Merit Award in 2017. He is a fellow of Aeronautical Society of India and life member of High Energy Material Society of India and Indian National Society for Aerospace and Related Mechanisms. At present, he is leading the INSAM Pune chapter as president and as vice chairman at the national level. He is also chairman of AESI Pune chapter. He is leading the High Energy Material Society of India as president at the national level. Please welcome Dr. K.
Thank you. Dikshita, I think it is a too long biodata you have read. Okay, very good morning to all of you. Respected D. Nageshwar Rao, President Vigyan Jyoti, Shri K. Harshchandra Prasad, General Secretary Vigyan Jyoti, Professor Manoj Gupta, National University of Singapore and Guest of Honor, Kal Venkat, Director, Faculty Development, AICTE and Guest of Honor, Dr. C.D. Naidu, Principal, Dr. B. Chennakeshwar Rao, Director for Advancement and Dean Administration, Dr. A. Subhananda Rao, Director R&D, Professor G. Srinivas Gupta, Convener, Professor Vice Shivaraj Narayan, Organizing Secretary, and all other distinguished guests, delegates, participants, and faculty members. A very good morning to all of you. Indeed, it is indeed an honor and a pleasure to me to address this August gathering of academia and research community on the inaugural occasion of AICTE-sponsored two-day e-conference on sustainable development in mechanical engineering, being organized by the Department of Mechanical Engineering, VNR VJIT, on the occasion at the time of Silver Jubilee celebrations. At the outset, I would like to thank organizers for inviting me and congratulate them for conducting the conference on a very vital theme, very important theme, which is highly relevant to this present day, that is the sustainable development, which is the concern of all. It is not limited to the mechanical engineering, it is to the entire world. And we have to deal about this sustainable development in every sphere of our life. My previous speakers have talked about this sustainable development in many ways, talking about advanced technologies and their sustenance, and then the research which is to be done, and defined in number of ways. But for me, sustainability, sustainable development, etc., it's absolutely, it is not a new concept. It is embedded in our growth of mankind or in our culture. Our society has survived over so many generations. That means it has subconsciously, it has practiced this sustainability. That is why we are surviving today. The definitions, concepts, approaches could be different, but they all inherently mean the same thing. We have to survive for a long period without affecting the nature. Because nature includes the human, nature includes the environment and our welfare and our growth. To give a very simple example, I'll say a typical Indian family, the head of the family not only takes care of the current well-being of the members in providing the food, or clothing or something, but also thinks of future, and then he tries to plan some of the activities and actions to ensure the well-being of that family in the forthcoming time, or maybe for sometimes even for future generations. Aspects such as education, finance, farming, housing are given a due importance, and they are meticulously planned so that the family status is always going on improving and the family is always in the comfortable position. Here the family, you replace the word with the whole humankind, then that's the same as the sustainability for us. Since ancient times, our culture gives importance to the waste management, water conservation, energy consumption, the three main things. And our houses were always designed to provide good ventilation and exploit the natural light for the best utilization. And we have been, in our childhood, most of us who are above 50s must have seen that one, how the rainwater is conserved at their homes, or even the used water is reused, given it to the plants and then conserved. Kitchen waste was never dumped. It was used as to make as a manure again. So everything is reused, recycled. In order to remain relevant with the growing population and the demands, unfortunately, we moved very fast with the industrial developments, ignoring the consequences. Over a period of time, man perhaps became less sensitive or less sympathetic to the environment in the pursuit of the comfort and the safety, became greedy, using the natural resources in excess, causing the pollution and environmental degradation. During the last few decades, situation became so serious that it is no longer feasible for any one of us to ignore what is happening around. We can't just overlook and go ahead. About 5 years back, even UN has taken conscious of this subject and addressed this issue and came out with, the way Dr. Subhanan has said, 17 goals and with 169 targets. There are many which includes the poverty eradication, quality education, sanitization, providing clean water, affordable energies, industry, innovation, infrastructure, and sustainable community, and so on, for achieving this sustainable development. The primary goal of the sustainable development is to meet the way it is defined is to meet the needs of today without compromising the needs of tomorrow. This means we cannot continue using resources at the current level, the way we are practicing today, as this will not leave enough resources for the future generations. We talk about the 3 pillars of sustainability are known to be the economy, society, and environment. Of course, economy is a subset of the society, and again, society is a subset of the environment. So we need to give balance between all the 3 pillars while pursuing our developments. Gain in one should not lead to the loss in another. So in achieving these sustainable development goals, mechanical engineers definitely can play a vital role. Who is mechanical engineer? Mechanical engineer is, after all, an engineer who applies the principles of simple engineering, mathematics, physics, and materials science for the analysis or the design or maybe manufacturing or maintenance or even operation of the systems. At the same time, he is also responsible. One should not forget about it. He is also responsible for the safe, sustainable, and cost-effective solutions for the design, production, and operation of these devices. Anyway, in the sector of design and manufacturing, the major contribution comes from the engineers. If engineers do not take care of the obsolescence, changing market needs, and the cost of the devices, the device will very soon become irrelevant and whole manufacturing sector becomes unsustainable. So that is why the engineers should address not only the design and manufacturing, but also the relevance to the society and or the need and the marketability and the safety to the environment. I would like to give you one example where the sustainability is ignored and then importance is given only to the economy. It is the United States of America has only involved in supplying the iPhones. It is designed it, but when it came to the manufacturing and assembly part of it, it subcontracted to other countries like China, Korea, and all these places. With this effect, the US has lost its edge over in the manufacturing because the manufacturing has not grown. On the other hand, China not only supplied the components, manufactured and supplied the components to the US, it also has explored the feasibility of developing its own phones and came out with a range of phones like Mi Range, OnePlus, Realme, and they flooded the markets with and it ultimately it beat this famed the Apple iPhone in some of the aspects. Due to this, the economy of the US started coming down and the economy of the China has started growing. Now today, the China became the second largest economy. Similarly, the Korea has also practiced and then came out completely. They designed, developed, manufactured everything. And the Samsung series of phone mobiles are even today are one of the best phones. So that is why engineers needs to be involved not only in the design but also in the manufacturing and its execution. To an engineer, a sustainable system is normally in terms of engineering. If I start taking that one, it is the one that is either it is in an equilibrium state or the one that accepts the changes at a very, very slow rate. Natural ecosystems, which consist of nearly a closed loops that change very slowly, are the best examples of sustainability. So we should take some of the examples from there. For example, in the food cycle, the plants and animals, plants grow in the presence of sunlight, moisture, and nutrients, and then they are consumed by the herbivores, like some of the insects. which in turn are eaten by successively larger animals, so that continuously producing some of the waste. All these resulted natural waste are again replenished into the nutrients, and these nutrients again help in the growth of the plants. It is a closed loop cycle. It is a natural eco cycle. And sustainable development in the mechanical engineering shall adhere to these principles of engineering in such as designing the products and processes in such a way that the waste from one are utilized or one are used as an input to the other processes. This is actually popularly known as industrial symbiosis. Using methods that minimize environmental damage, incorporating environmental and social constraints, as well as economic considerations into the engineering process. Using energy and resources at a rate that does not compromise the natural environment or the ability of the future generations. This is the basic principles. As I belong to the defense R&D, I can categorically state that sustainability is an integral part or the top priority parameter that is considered in defense R&D or defense industry and development. In case of defense equipment, normally we define about the reliability, durability, survivability, sustainability, and so on. So it's so many abilities we ask for the defense equipment. All these abilities to be provided by the designers during the design and ensure that it is in the development and sustained during the induction. Every aspect of this, all these reliability, desirability, survivability, sustainability, vulnerability, and so on, all these abilities are given a due weightage. The equipment needs to function satisfactorily over a long period and should be able to maintain over a few decades. This means the life cycle management is a very, very critical issue, and that is always addressed during the development and subsequent induction. The only way to ensure the reliable performance or the sustainability, survivability, or the maintenance of our equipments is to overcome the obsolescence over such a long few decades. This is the only way is to achieve is the day the country develops the self-reliance, the country can sustain. So self-reliance is in turn ensures this sustainable industrial growth, sustainable employment growth, and economy of the country. So about last, I can say about in early 1990s or the last about 3 decades, DRDO has been focusing on self-reliance in the areas of technology as well as the manufacturing. We have achieved self-reliance in many areas to a great extent, like in the areas of high energy materials, like explosives, propellants, and so on, and structural materials, and power sources, controls, guidance systems, and so on. Many areas which are required for development of armaments, military vehicles, fighter planes, guided missiles, electronic warfare, and so on. The technologies are indigenously grown and developed, and they are being transferred to various industry through liberal policies for propelling this industrial participation. The policies of and the programs being pursued by the government over the last 5 years, such as Make in India, Startup India, Stand Up India, defense corridors, and also incubation centers, all are resulting in expansion of our defense industry and participation of academia in the defense more and more. This is an essential development which is required for our economical growth as well as the social development. DRDO is also stressing on the designs to be environmental friendly. It is not that we only talk about long functioning and over a long period with reliable performance, we do have a concern to the environment. We have taken several initiatives to move from the hazardous processes to the greener processes, to avoid or minimize the pollution, and to use minimum non-renewable energy resources. We are focusing on green energetics in the areas of high explosives or propellants. Like, for example, we are moving towards the ammonium dinitramide as an oxidizer in place of ammonium perchlorate, which reduces the pollution at the launch sites for solid rocket propulsion. Green primary explosives, which are may not be producing too much of pollutants, but they are hazardous to the human who is operating. So we are trying to move to the green primary explosives. That is basically the lead-free primary explosives. And we are moving towards the nuclear energy sources for submarines and its operations, use of now robotics in the hazardous operations, artificial intelligence, and so on. And we are trying to minimize the hazardous effects on the humans who are operating, and as well as we are trying to reduce the pollution which is generated and it is being left into the environment. Earlier, you must have read in many articles that the expired munitions are used to be dumped in the sea, causing a damage to the ocean life. Or sometimes they are demolished in the open grounds, causing sound and chemical pollution to the environment. To minimize the use of these methods, several initiatives are initiated in DRDO to design disposal plants where the controlled burning takes place and the effluents are treated well before leaving it to the environment. And the ingredients are extracted and reused. At the end, I would like to bring out that for ensuring sustainable development, mechanical engineers shall focus mainly on development of sustainable materials, development of alternate fuels, making solar energy affordable for the society, providing energy from nuclear fusion, achieving zero carbon emissions, restoring and improving urban infrastructure, providing innovative solutions in the areas of healthcare, energy, water management, agriculture management, etc., by working in the emerging bio-nanotechnologies, creating affordable, innovative engineering solutions for the poor and deprived. I strongly believe that engineering profession can play a vital role in addressing these issues of environment, economy, and society tactfully and ensure the sustainable development. I also believe that this conference will be able to bring out diverse ideas into a lively and meaningful academic discourses. These in turn will be useful and helpful to formulate the research ideas into sustainable product and solutions. I would like to thank all the speakers from India and abroad, presenters and others, and the audience who will contribute during the next 2-day deliberations of this conference. I wish all a good luck and I wish the conference a grand success. Thank you.
Thank you so much, sir. We are very grateful to you for accepting our invitation and marking your presence here. I am profusely elated to take an opportunity to introduce our guest of honor, Dr. Manoj Gupta Garu. Dr. Manoj Gupta Garu was the former head of Materials Division of the Mechanical Engineering Department and Director Designate of Material Science and Engineering Initiative at NUS, Singapore. He did his Bachelor of Engineering from VRCE Nagpur in 1984, first class with distinction, Masters of Engineering from IISc Bangalore in 1987, gold medalist, PhD from University of California, Irvine, USA 1992, and postdoctoral research at University of Alberta, Canada 1992. In August 2017, he was highlighted among top 1% scientists of the world position by the Universal Scientific Education and Research Network and among 2.5% scientist as per ResearchGate. To his credit are integrated MELT deposition technique and hybrid microwave sintering technique to synthesize alloys or micro or nano composites. He has published over 580 peer-reviewed journal papers and owns 2 US patents and 1 trade secret. His current H index is 67, RG index is 47, and citations are greater than 17,000. He has also co-authored 6 books published by John Wiley, Springer, and MRF, USA, and edited many others. He is editor-in-chief, editor of 12 international peer-reviewed journals. In 2018, he was announced World Academy Championship winner in the area of biomedical sciences by International Agency for Standards and Ratings. A multiple award winner, he actively collaborates or visits as invited researcher, visiting and chair professor in Japan, France, Saudi Arabia, Qatar, China, USA, and India. Please welcome Dr. Manoj Gupta Garu. Sir, your mic is mute, sir.
You can hear me now?
Yes, sir.
Okay, perfect. So I'd like to thank Dikshika for introducing me. I'd like to thank the VNR VGIT to reach me and giving me the platform to express myself. It's a real honor. I'd like to congratulate them for being sustainable for 25 years, celebrating your silver jubilee. Hopefully you will go on with very flying colors. And thanks to the management pillars and the dignitaries of VNR VGIT who came out with a vision to organize such conferences, which is very useful for both the student, researchers, teachers, and attendees. I would like to also tell to the audience that such an opportunity is very useful. The countries who are in forefront in the world are the one who are working on the knowledge-based economy. So knowledge-based economy is the way to go now. If you want to be prosperous, you have to learn, unlearn, and relearn, because whatever was in the past may not be valid now. There's a totally new technology, and the most difficult part is to unlearn, because you have learned something and you don't want to give it away. So keep your mind open. And also through this kind of platform, I'll advise everyone to multiply your knowledge. And the way you multiply your knowledge is when you receive the knowledge from the people, the speakers in the conference, and you share with your colleagues. And during the process of that, you end up in a meaningful conversation, debate, discussion, and you can find even better ways, because it's not like we have the ideal ways at this point of time to do something. Things keeps changing, and once you do that, I think you will do wonderfully to your own career. You will benefit the society, so you become a very meaningful citizen, and also you will do a wonderful job for the progress of nation. So I wish you people all the best in learning through this platform, and I conclude here. Thank you very much.
Thank you, sir, for providing your gracious presence to join us today to announce our joy. Next up, I feel honored to have with us Colonel B. Venkat Garu, Director AICTE. Colonel Venkat is a serving Army officer from the Technical Branch, Corps of Electronics and Mechanical Engineering, having done his mechanical engineering from Army institutes. Having 3 decades of service experience, the officer is presently on deputation with AICTE and is handling faculty development related issues and grants pertaining to faculties through AQIS schemes. He also handles the NITTT, National Initiative for Technical Teachers Training, which is now mandatory for the purposes of regularization and promotion to all teachers. Please give a warm welcome to Colonel B. Venkat Garu.
Thank you. Thanks a lot, Dikshika Yadav. In case if you can hear me, just acknowledge.
Yes.
Perfect. Thanks a lot. And Thanks to everybody, especially the Institute Vision SGIT, for actually giving me an opportunity to come on this platform and speak. I was hearing the previous speakers, and it's actually speaking, to hear one of the best speakers speak and come out with such an actionable roadmap, the plan, the activities which should have been done, which needs to be done, and the way it was supposed to be carried out. It's so commendable. Even I got to learn a lot of things. And Professor Murthy, sir, in case if suppose I can quote your talk, which you said it was one of the best talks that I have heard. I would be quoting your conversationals and your talk in every forum that I generally go. I keep speaking on a lot of platforms. I appreciated your concept as to how China, from where to where they reached, and what all actionable plans that we as a country missed out, and where all should be our focus. Fabulous, sir. And I only hope, in case if today I also am going back with some value additions from the talks which I am learning, I only hope that when I see your attendance, it's so wonderful to see a conference of this nature, having very senior functionaries coming and speaking. In case if suppose the audience is listening, please do understand that these people are supposedly the best in their field. You cannot have an audience from people like this on a regular nature. So in case if they speak something, please do take back as a very positive kind of talks. And sir, with your permission, I have recorded your talk also, sir, on my mobile. I found it fabulous. And in case if suppose I find it, I only hope that others also. And that goes to show that the institute has put in so much effort to actually speaking identify the right kind of people for the subject. Now, this is where the management of the institute also deserves accolades. It's perfect. It's very well that people will come and speak and go back. Conference can happen like this. Many more will happen. But the best part is, in case suppose as organizers, you can go back and actually convey that people who have gone back have returned back or given a feedback or asking certain queries. I think that is where you people should be very, very proud of yourself. And I can assure you only one thing, sir, in case suppose this is how the speakers level is for this conference, I would recommend any other institute also to, slightly improve conduct. Fabulous, sir. It was wonderful to be associated, sir, for information of everybody, because I do understand that most of them would be faculties and industrialists or academia or from the research background or people associated with the subject. I am Colonel Venkat. I do look after the faculty and its related issues at AICT. Possibly I do also handle each and every grant related matter. So please feel free to get in touch with me at any given time. My mail ID and mobile number is known to everybody. If there's any issue, any query, any matter which there is a doubt, anything which you feel that needs to be clarified, please do fall back on me. And I can assure you only one thing, that I receive a mail or a WhatsApp, I'll surely answer back. In case if suppose the reply is within my ambit, I'll surely give myself, or in case it's beyond me, I'll make sincere efforts to get in touch or connected you to the right persons in AICT or any other central regulatory or government body from where you can get a fruitful answer. I congratulate once again VGIET, VNR VGIET, for a very, very wonderful online conference which they have done. The topic itself was so relevant, sustainable development. It's very long, that I heard this topic. Very long. You people do need to understand. Unlike me, my very esteemed speaker, Professor Murthy, when he spoke, he is a man connected on the ground. He's an absolute people connected on the ground, and even speakers before him. My apologies, I joined a little late. So for me, coming and listening this topic was fabulous. Hopefully people going back are taking some very positives. Do not stop here. This conference should be a start point or kind of a catalyst or a precursor to many more activities which are likely to come. For information of everybody, just as a agenda point, beyond this particular conference, AICT would be advertising the AQIS 2021 first week of November. That is, all financially funded schemes would be open for you people to apply. This conference also happens to be one of the AICT funded schemes, which is going by the name AQIS. So please do apply, and I don't have any doubts. In fact, I'm very sure that in the coming few weeks and months only, we would be seeing your name once again in many more approved activities. Compliments once again, compliments to everybody, and my sincere apologies in case if suppose I have joined late. I didn't mean to offend anybody. It was just that there was some other activity which was binding us down. All of you know, with the national education policy now having been already announced, the government is going at full scale to implement. Now, having a policy is one thing, how to implement is something very different. So today we are in the dynamics of implementation. So we are involved day in, day night as to who will be doing it, what time frame, when. So that's the reason that I was slightly occupied. I only hope that you people will not take it as any kind of any other subject on my side. It was a sincere apology, and I would appreciate from the bottom of my heart for the institute to please carry out many more activities of this nature. And one last sentence before I go, please remember that the online platform is a boon, and at the same time it can work other way around also, because this is the first time when you people are coming on an online platform and speaking. Your reach, your outreach, if the right word is there, is going much beyond your immediate vicinity and neighborhood. Earlier, when you people used to always have a face-to-face, it's only that limited 30-40, preferably from your own home state, Andhra. One odd would be from neighboring states. So today in an online, please go through the diversity of your participations. People, they must be from all across India. So please do understand, this online is nothing but your own advertisement, an advertisement for the speaker, at the same time an advertisement for the institute. And let me assure you, you people handled it fabulously. It was a wonderfully organized conference. Thank you once again. Thank you. All the best in your future endeavors. Thanks a lot.
Thank you so much, sir, for your words of wisdom.
Thank you, ma'am.
Sir, your mic is mute.
In the august presence of today's chief guests, guests of honor, and other dignitaries, we would be releasing the souvenir of this conference virtually. Just wait a minute. Dikshika, continue.
Now, I would like to request K. Jayaprakash Garu, Assistant Professor, Department of Mechanical Engineering, VNR VJIT, to deliver the vote of thanks.
Our esteemed Principal, Dr. Sdme Garu, Honorable Chief Guest, Dr. KPS Murthy Garu, Director, HEMRL Pune, Honorable Guest of Honor, Dr. Manoj Gupta Garu, National University of Singapore, respected Colonel Venkat Garu, Faculty Development, AICTE, respected DN Rao Garu, President, Vijnana Jyoti, Shri K. Harishchandra Prasad Garu, General Secretary, Vijnana Jyoti, Dr. B. Channakeshwara Garu, Director for Advancement and Dean Administration, VNRVJ IET, and Dr. A. Shubhananda Rao Garu, Director R&D, VNRVJ IET, our invited global guests, ladies and gentlemen, it's my privilege to propose the vote of thanks on this occasion. It has been our pleasure to welcome the participants across the globe for the e-conference at VNRVJ IET. We are happy and fortunate to have the eminent persons from academia, industry, and R&D labs in the streams of mechanical engineering as session chair, and we are thankful to all of them. We sincerely thank the members of the Advisory Committee Sdme 2020 for their valuable suggestions. We are happy to thank our chief guest, Dr. KPS Murthy Garu, Director, High Energy Materials Research Laboratory, HEMRL, Pune. We are all inspired by your great words, sir. Murthy, sir, thanks a lot for your presence. We would like to acknowledge the guest of honor, Dr. Manoj Gupta Garu, National University of Singapore, for gracing the inaugural occasion. Sir, we are feeling very proud of you, sir. Thanks for your presence in our international e-conference, Dr. Manoj Gupta Garu. Thanks a lot, sir. We also wish to express our gratitude to Colonel Venkat Garu, Director, Faculty and Development, AICTE, New Delhi, for accepting our invitation. Thanks a lot for your inspirational speech, sir. Venkat Garu, thanks a lot. We also thankful to Dr. DN Rao Garu, President, Vijnana Jyoti, and Shri K. Harishchandra Prasad Garu, General Secretary, Vijnana Jyoti, for motivating our heart to conduct the conference. Sir, your presence is more encouraging for us to conduct these programs in future as well. We appreciate the guidance from Dr. B. Channakeshwara Garu, Director for Advancement and Dean Administration, VNRVJ IET, and we thank Dr. A. Subhananda Rao Garu, Director R&D, VNRVJ IET, for invaluable advices in organizing the conference Sdme 2020. We thank Dr. Sdme Garu, Principal, VNRVJ IET, for inspirational thoughts and support in all aspects in conducting the conference. We acknowledge the sponsors of the conference for their financial and technical support. To list, AICTE, and special thanks to Lokesh Machine Tools, Hyderabad, Makerboat Industries, Hyderabad, VSD 3D, Hyderabad, CanterCAD, Hyderabad, iForge 3D, Hyderabad, Shigemi Scientific Solutions, Hyderabad, Invoke Enterprises, Hyderabad. So we are very thankful to all the sponsors, sir. Without your technical and financial support, this would not be happened. At the end, we also acknowledge the unwavering support received from Dr. G. Srinivasa Gupta Garu, our beloved HOD, the faculty, and all the staff members. We are fortunate enough to be backed by a team of very motivated and dedicated colleagues of mechanical engineering, VNRVJ IET, who coordinated for organizing the conference. We also like to mention VNRVJ IET administration for providing us all possible logistic support towards organizing this event. I thank keynote speakers and the delegates for their enthusiastic participation in this conference. I take this opportunity to thank all the reviewers and the technical committee members for providing their valuable comments in time and help towards the improvement of the quality of the papers presented in the conference. My thanks to everyone enough for their precious time in organizing and involvement to take on the completion of the tasks beyond their comfort zones. Thank you all. Thanks a lot.
Thank you so much, sir. I would like to thank everyone who joined this inaugural function and made this possible. Along with it, special thanks to our dignitaries and speakers for gracing the occasion. A small announcement: keynote lecture on sustainable magnesium and its technology for engineering and biomedical sectors by Dr. Manoj Gupta, Associate Professor, National University of Singapore, will start at 11:40 a.m. Participants are requested to kindly join with the same link. Thank you.
Thank you.
sir.
So we can stay in this link, right?
Yes, sir.
Okay.
Yes.
And how much time lapse is now? When I have to start this one?
11:40, sir.
Which is 5 minutes from now, or
Yes, yes. It's almost 5 minutes, sir.
5 minutes?
5 minutes.
Okay. So in the meantime, I can.
You can take a break, sir. Yeah.
Yeah, I'll just take a 2 or 3 minutes break, but I share the screen in the meantime
Yes, sir.
so that we can start window share. So my screen is there now, right?
Yes, sir. It's visible.
Okay. Perfect. So I'll just take a 2 minutes break and then I come back.
बड़ा अच्छा है उधर उसका बैग ना तुम डिस्टर्ब हो रहे हो ना मैं डिस्टर्ब हो रही हूँ हम से बिल्कुल बड़ा तो देखो वैसे बड़ा अच्छा लग रहा है कि जो आएगा आएगा मतलब all this is given to my next doctor. Then you want to tabulate with knowledge of what we know.
Yeah.
Welcome back. It's my privilege and honor to now to invite Dr. Manoj Gupta sir, Associate Professor Materials Group, Department of Mechanical Engineering from National University of Singapore to deliver the keynote lecture on sustainable magnesium and its technology for engineering and biomedical sectors. Please, sir.
Can everyone hear me?
Yes, sir, it's audible.
Very good. Welcome everyone. In the second session, it's my privilege to highlight the importance of a very emerging magnesium technology. And you know, the focus of this conference is sustainable. So I will indicate to you how magnesium is sustainable material and how it, along with technology, is going to be a very strong force in material science and also in the manufacturing sector of the practically all the countries in the world. Magnesium is a very unique material. It can be used in both engineering and biomedical sector. It has a history of about 100 years. And essentially, if you look at the pictures at the bottom of this slide, you will see that way back in 1943, during the Second World War, all these nice ladies here were using magnesium for if you can read the word, to make tracer bullets, bombs, and lightweight equipment. So the concept of lightweight existed during the Second World War, which is now so much talked about in the modern world. The prime reason was the presence of the fossil fuel during the Second World War was restricted because of the war going on. 1947, this material was used in the aerospace sector. This is a year in which we got our independence. And in 1950, we have seen this material emerging in the automobile sector. So practically defense sector, aerospace sector, and automobile sector were actually looking for this kind of material. So now, with the global warming, there are a lot of pollutions, as you have heard in the inaugural address about an hour back, is how do you choose a material in 21st century? First thing, it has to be abundant, sustainable. That means if you're using it now, you should be able to use it in future also with equal ease. It should be non-toxic, because many of the material which we have used in last century are very toxic. Every country is spending billions of dollars now to clean up their water bodies, to clean up the landmass, and to clean the air also. Now, your material can be sustainable, it can be non-toxic, but at the same time, it should display acceptable properties. If the properties are good, you can use it in the application. If the properties are not good, sustainability will not do anything, non-toxicity will not do anything. Next thing, cost-friendly. Your material has to be not too expensive. So if it's too expensive, it cannot benefit an ordinary man. But if it is cost effective or it's cheap, then its application can be used by an ordinary citizen. And another interesting factor, the geopolitical issues. You don't want to use a material which is controlled by one country or two countries, because in future, if you have or your country has a political issues with this country and they stop the supply of this material, the whole of your industry will sink. And that is where you have to ensure that when you select a material or a suitable material, it should be available from multiple resources. So once you tick up all these circles here, you are getting a wonderful material, and magnesium fits the bill. So why we want to use magnesium? Some of the elements of this word you have already heard it about 1 hour back. It is very important for a happy planet Earth. It is very important for happy plants, for happy humans, and for the animals. And I will take you through of how it is important for a happy planet Earth. We are facing the issue of global warming. Not only we, the whole world is facing. In Chennai, we have seen flash floods in 2015 and near drought in 2019, which is last year. Then you have seen the forest fire in Alberta, Canada, which is like at -10 degrees centigrade because the air was too dry and warm. Then you have the France sizzling at 45 degrees centigrade in 2019. So essentially, you see that this kind of weather fluctuation to the extreme end was not happening a few decades back. It has started happening on a visible note in last few decades, I will say 3 decades, and this can all be related with the global warming. These kind of sites, big icebergs, are floating now. They detach from the Arctic Circle and then they come floating. That is an indicator that ice in the Arctic Circle or Arctic Sea is melting. The level of the sea is rising. So now you see that you can see the green hues in the Arctic Circle because now the ice layer is less thicker, sunlight can penetrate, and the plants are now growing up, and these are all phytoplanktons. So basically, after recording the significant weather changes starting from 1990s, all the countries came in to come out for Paris Agreement, which was ratified in November 2016. The whole idea is to keep the temperature rise to below 2 degrees centigrade, and they are targeting not to exceed 1.5 degrees centigrade above the pre-industrial level, which is a year 1880. Currently, we are at about 1.2 degrees centigrade. That gives us a window of only 0.3 degrees centigrade to work on. What happens if the global warming exceeds 1.5 degrees centigrade? All the catastrophic events, their frequency will increase, and practically all of us will be affected by what you have seen, the flash floods in Chennai, where we lost billions of dollars in terms of infrastructure damage. And if it goes beyond 2 degrees centigrade, that is considered as a tipping point. That means now you have no control on the environment, and that is a catastrophe for the whole planet. The target is to reduce the carbon dioxide emission by 2 billion tons in 2025. This target was set about 2 years back. Now, COVID-19 has come as a blessing in disguise as far as the global warming is concerned, because it is estimated that we will be able to cut down 2.5 billion tons within this year because of aerospace sector is not working, transport sector is at standstill for many months. So it can be seen as a blessing in disguise from the global warming point of view. But of course, there's a lot of human suffering which has come with that. So it's going to affect. Now, if you have to improve the health of planet Earth, for example, then or you have to go for a sustainable Earth, you have to cut down on the carbon dioxide emissions. And one of the sectors which really affect the carbon dioxide emission, which is very relevant to mechanical engineer, materials engineer, is the transportation sector, which accounts for 31%. Electricity sector, of course, we are making progress in renewable energy and the nuclear energy. Industrial sector, they have to use the cleaner fuels. So essentially, the idea is to reduce the fossil fuel consumption and to reduce the emission of carbon dioxide to the environment. And one of the ways, there are many ways, one of the ways is to reduce the weight of the movable things like your car, like your bus, like your train, like your plane. Once you reduce the mass of this vehicle, you burn less fuel per kilometer. And by doing that, you reduce the emission of carbon dioxide, thus helping in mitigating the effect of global warming. Many countries all over the world are working in that direction. In 2010, European Union set up a goal to reduce the fuel consumption by about 25% by reducing the weight of the cars. That means emission of the carbon dioxide has to reduce from 130 grams of CO2 per kilometer to about 95 grams of CO2 per kilometer, which is about 30 to 35% reduction in the CO2 emission. So you are targeting a 30 kilometer per liter mileage of the vehicles that you are using. So where we are, is this global warming such a fiction of the researchers and scientists? Not really. If you look at the health of the planet Earth at this point of time, you'll be surprised that we are already in the mass extinction event, which is a 6th mass extinction event. When you use the word mass extinction event, that means you lose 70 to 95% of plant, animals, and microorganisms. The previous 5 happened because of the natural causes, and this one is happening because of the humans' activity. The CO2 is highest in last 800,000 years at 403 to 407 parts per million level. Your Arctic ice is melting. Low-lying countries will start to disappear within 5 to 10 years slowly, because all this rising water is going to eat away their coastal areas. It is already 8.5 centimeter increase in the sea level, and they're expecting by 2050 it can be as high as 1 meter if the melting continues. And the number of extreme events from 1990s to 2015, such as droughts, forest fire, floods, tropical storms, have doubled, and it is going to increase even further. So based on that, the doomsday clock, which if it is at 12 o'clock means it's a doomsday for the humans, many of us will not survive it. And that is moved forward or backward based on 3 main parameters: proliferation of nuclear weapons, the climate change, and the new technologies. See the word nuclear weapons. It's the second, climate change, which we are experiencing already. New technology, because most of the technology we have used in the past century have toxified our water bodies and land bodies and so on and so forth. So if you're aware of this Mayan, one of the ancient culture, they predicted the end of the world in 2012, 21st of December. But nothing really happened. But we see the countries coming together to formulate the Paris Agreement at that time. Now, maybe I clicked the wrong window. So let me go back to my slide. Okay, presenting to everyone, stop presenting. I'll come back to this slide again. Okay, here we are. So basically, we are talking of the Mayan calendar. Now let's go to the Hindu philosophy of the Kali Yuga. Kali Yuga is supposed to end in 2025, and that is where the Paris Agreement has created a target to cut down the emission of CO2 by 2 billion tons. So what do we see here is that spiritual understanding and scientific predictions are coming together, and they are targeting 2025. So maybe the end of Mayan calendar and the end of the Kali Yuga gives us a window of about 13 years to put our action right. If we don't do that, we are going to face the consequences of that. Now, the young generation is very well aware, and that is what the awareness should be in every country, all the way from UK to USA to South, to the African continent, to the European continent. Everywhere people want green material, green technology. So it will be against the professional ethics very soon for an engineer to use a bad material or a toxic material and a technology which toxifies our planet. Now let's try to understand how magnesium is useful for the plants now. Whatever goes in the soil or the water can be absorbed by the plants. The work done in Australia have shown that for a soil which contains gold, can absorb the golds in its transportation system. That means it roots, stems, and leaves. And you see these images, all these bright areas shows the presence of gold and manganese. So that tells you one thing, that if you put anything in your soil or land mass, it may end up on your dinner plate. No matter how well you eat healthy food like spinach and all this thing, but inside the spinach, you have the contamination which is going to adversely affect your health. Aluminum is one of the lightest weight element which we use currently, but aluminum, if you look at its effect on the plant on this image on your right hand side, the root growth is stunted. If the root growth is stunted, the plant growth will be stunted. That means aluminum is a toxic material for the plants. And if it's a toxic material to the plant, the growth of the crops will be affected. And if it is affected, that means many more people will go hungry. Now, for plants to absorb aluminium, the soil pH has to be less than 5.5. But 60% of the world's potential crop growing soil is very acidic. So that means we can use aluminium, but we cannot afford to dump it illegally. We have to properly recycle it. On the other hand, if you use magnesium, you look at the growth of the root of the plant here, which is in a magnesium sufficient soil, and you see it's much higher growth of the plant. That means the magnesium is a nutritional element for the plants. Now, let's look from the perspective of healthy humans and the mineral. The dogs drinking contaminated water can turn blue. This image is from Mumbai. If you have seen the Hollywood movies Avenger, you see the Hulk, whose body is contaminated deliberately in that case. So all these things, what you can see is that human may start changing the color if they are continuously being contaminated by the contaminated water and the food. So we have to take a preventive action now before it is too late. And if you see the image on your right hand side, you see how the presence of pollution, whether say air pollution, water pollution, soil contamination, can lead to all kind of health issues all the way from your brain to your intestinal canal. And that also includes the cancer. The number of cancer cases are increasing. So how magnesium is for the human health? It is involved in 300 chemical reaction. It's required by the muscles, it's required by the nervous system, it's required by the cardiovascular system, immunity system, and if you have trouble sleeping, you can always eat magnesium. Now, magnesium is also the fourth most abundant cation in the human body. So our body needs up to 400 mg of magnesium every day. Anything in excess, body knows how to take care of it. It comes out in urine. So it's a very safe material to use. Now, how about aluminium? 3.8 million tons of aluminum was generated in 2017 and 2.7 million tons was landfilled. So if aluminum enters our food chain, it can lead to the cognitive deficiency, dementia, adverse effect on central nervous system, reproductive system. It's linked with the old age diseases like Parkinson and Alzheimer's is established because it can go and deposit in the brain. The people who are susceptible are the young people, I will say infants, elderly people, and patient with the renal function. And accordingly, the World Health Organization is continuously reducing the recommended intake of aluminum by the humans. Magnesium can also be used as a medicine because it takes care of the tinnitus, which is a situation when you hear the sound when it does not exist. So with the magnesium dose and vitamin A, C, and E, you can also control tinnitus. Since magnesium is biocompatible, it's a nutritional element, it is also used as a biomaterial for making stents and the orthopedic implants. Germany is doing a good job in there. Magnesium is also used to mitigate electromagnetic radiations. Now, all of us use the electronic gadgets. Practically each of us have a mobile phone these days. If you go to the kitchen, you have fridges, grinders and everything. You go in the living room, you have TVs, laptops, anything which is electronic generates electromagnetic waves. So it is the fifth largest pollution with no boundary after noise, water, air, and solid waste pollution. And when you use anything or when you're in the close proximity of the electronic gadgets, this radiation produces a current in the body, which body does not know how to handle it. And that affects the metabolism of the body and the hormonal production. And as a result of that, you can have cancer. And that is why the World Health Organization has classified the electromagnetic radiation as a group 2B, possibly carcinogenic. And the worst part is that because of the proliferation of the electronic gadgets, every human being is susceptible to the electromagnetic radiation and subsequent cancer if you do not control it. And remember, this radiation damage is accumulated in the body. So when you grow old, then only you start seeing the effects of it. So we try to test magnesium against the commonly used aluminum. And we found that both in radio wave frequency and the microwave frequency, magnesium is superior to aluminum or similar to aluminum. So why do I want to change aluminum by magnesium? Only reason, it is non-toxic. Second reason, it is lighter. It makes your phone lighter, it makes your laptop lighter, it makes everything that you carry lighter. So, and the good health benefits. So it's the time to use magnesium. There are certain positives of the magnesium. It has a lowest melting point among the commonly used structural material. Its density is lowest. Specific strength is one of the best. Damping or resistance to vibration is excellent, and electromagnetic shielding is also very good. It has acceptable ductility, modulus, and the cost. It has only negative is it can corrode in the wet environment. So like irons and steel, you have to find the surface protection measure such as the painting. So let's try to compare it with the aluminum, which is by volume the most widely used metallic material, and steels by weight, which is the most widely used metallic material. Now, if you look at the graph on the left-hand side, you see that density of magnesium is the lowest. So it has the most potential of fuel saving. Its melting point is lowest. That means you spend less energy in making it. Its specific modulus is similar to titanium and steels, no problem. And specific strength is next to the titanium, which is at least 5 to 6 times more expensive than magnesium. Now, if you look at the chart on your right-hand side, you see that for a nice range of the strength values, which is on the y-axis, it gives you the best weight reduction when compared to aluminum, titanium, steel, and nickel. Further, it can be turned into finished product faster. That means it's economically attractive. Instead of making 100 pieces a day, you can make 1,000 pieces a day. And that is an advantage of ability to produce it faster. So are we short of magnesium? Not really. It's the 6th most abundant element in the earth crust, and it's the 3rd most dissolved mineral in the seawater. By mass, it is next to iron, and it is 12 times more than aluminum. So if you can use aluminum for 1 century, you can use magnesium for 13 centuries. How about the universe? And you'll be surprised that magnesium is the most abundant metallic element, even much more than iron. So I always tell that magnesium is the God's own element. So in future now, everyone is talking of colonizing Moon or Mars. You can always take magnesium and magnesium technology, and you can expect it to find it on these planets also. So what happened between Second World War and now is why the magnesium was forgotten. Maybe people were not aware of the light weighting, they forgot about it, and they were not able to see the climate change. So this picture comes from Finding Nemo, where the research community is asking the industry, why you give up on magnesium? And this fish, blue fish, was supposed to have a short-term memory loss. She says 50 years of memory loss. But in 2020, the people were already starting to work very aggressively on magnesium. So to further strengthen and to eliminate the fear factor, because many of us knows from our chemistry lab that it is flammable, but that's a very wrong concept. Now, you see in 1950, you've seen this image beetle, they used 20 kg of magnesium. It was used in the engine application. So if it is flammable, how the country or the companies can use this in the engine application? Now, 2012, GM, General Motors, started using magnesium in the boot area of the car. Simple selling point, 75% lighter than steel and 33% lighter than aluminum. Porsche, another brand name, started using magnesium in the roof area, and they were able to save 10 kg just by this changing this small area of the sheet here. And they compared with aluminum and carbon fiber reinforced plastic, and they say that it is the cheapest, lightest, and very durable. South Korea did a wonderful job to create a roadmap. They started in 2004, become independent in magnesium technology within 15 years time. And they are already using in the vehicles, in the steering wheel, in the lamp casing, and so on and so forth. Now, if you look at a car, for example, it gives you which all parts you can replace the existing materials based on aluminum and steel with magnesium, effecting a weight saving. Even the US is looking into that, and in way back in 2010 they were using only 5 kg of magnesium, which they plan to increase to 160 kg by this year end, which is about 3200% increase. Many of these things are outsourced to country like India, and if we do not take a preemptive action in developing this technology and create infrastructure, we will lose this billions of dollars of business. How about the aerospace sector? It started way back in 1947 in Convair Peacemaker. They use 8.6 tons of magnesium. Sikorsky helicopter used 115 kg of magnesium. Lockheed F-80C was totally made of magnesium. Russian bomber used 1.5 tons of magnesium. As a result of that, after a lot of deliberation, Federal Aviation Authority lifted the ban of using magnesium in commercial aircraft. They say that it should just undergo a testing for the flammability, because the people are saying that in a typical small Airbus plane, they can save 360 kg, and if it is A380, you can save 4.2 tons just by replacing the seats on which the people sit, and that will translate to reducing the carbon footprint tremendously. How about in the maritime? Amphibious vehicle, war vehicles, or vehicles which can move in the land and in the water, needs to be lighter so that they can work for longer time, longer duration on the same amount of the fuel. That is where the magnesium is being used. In US cruise ships, the engine blocks are made of magnesium. The countries like Singapore is investing in taking magnesium to the defense area, where the armed robotic vehicles have been designed for magnesium, because they have done their own calculation saying that for a 6-ton armed robotic vehicle they save 1 ton, which is 17% saving, and for a big armed robotic vehicles of 25 tons they can save 3.75 tons, and that's a tremendous amount of fuel saving, allowing their vehicle to be in the war zone for a much longer time and do their function. And I have not talked about structural component in electronic sector, such as in the camera body, TV bodies, and the Samsung phone that you use. The body is already made of magnesium, good for lightweighting and good for electromagnetic shielding. All the robots are typically made of steel, very heavy, use a lot of energy for the movement, replaced with magnesium. High-speed trains, the people in Japan are doing the system level testing to replace all the steel sleeper berths from magnesium, reduce the weight, reduce the energy consumption, save on the cost of travel. The processing technique that we developed in National University of Singapore in my group were based on the liquid metallurgy route and powder metallurgy route. We developed a lot of magnesium-based materials, including nanocomposite. The disintegrated melt deposition technique, which we innovated way back in 1995, have a graphite crucible. You put your material in there, you heat with the resistance heating furnace, you homogenize the reinforcement and the alloying element, you bottom pour it, and when you're pouring it, you hit with the argon gas jets to get an ingot at the bottom. Very cheap. In a few lakh rupees, you can establish that in India. You get ingot, which can be used for engineering application. You can extrude it, roll it, forge it as the end application be. The second method of making the metal-based material is the powder metallurgy route, where you can take the different powders or ceramic particles. If you're making a composite material, you can blend them using a blender or ball mill. You can compact them into billets like that, and you sinter them. Sintering tradition is done by tube furnace, but we use microwaves. A microwave, something which many of you will be having in your home. Nothing very fancy, just buy from the market. Anyone can use it to make high quality material. How do we do that? Because of this, if you look at this table, we can save the duration by 90%. We can save the energy by more than 90%. That means saving the duration of the production, you are almost increasing the production by 90%. You are almost cutting down the cost, energy cost by 90%. That is the advantage of using microwave. So you take your material, you put in a crucible, and you put the microwave susceptor, which is silicon carbide, and you put another crucible and enclose that into insulation so that you're able to contain the heat. Switch on the microwave for a pre-calibrated time, and you get the sintering in 14 minutes instead of 170 minutes used in the conventional ways. So microwave goes and absorb in the billet and heat it up in a very quick time using a two-directional heating. You can get a sinter blade, and again you can process it. Remember, the oven is only 900-watt oven, 2.45 gigahertz, same oven as you use in your kitchen. So once you use a wonderful process, a material, it is not good for application unless you characterize it and prove it that yes, its properties are also good. So we focus on nanocomposite was one of our focus, in which we put nano-sized particles such as Al2O3, silicon carbide, boron carbide in there, and they can be called as nanocomposite. So we don't use the micron sized particle which you see in the left hand side image, because they have certain issues of particle breakage as you see in the left hand image, or the debonding which you see in the right hand image. And with that, you can increase the strength, but you don't increase the ductility. The material becomes very brittle. You compromise almost 80% on the ductility and the fracture toughness. So by putting the nano-sized particle, you can improve the ductility of magnesium, modulus, dynamic properties, high temperature stability, creep properties, wear properties, fatigue properties, dry and wet corrosion resistance, ignition characteristic, electromagnetic interference, and the bioresponse. So I'll give you certain quick examples here. For example, you can even reinforce magnesium with another metal element like aluminum, and you can increase the strength from 134 to 218, about 30% improvement. UTS you can improve by another 30%, and you also improve the ductility to 1.5 times roughly. Simultaneous improvement in the strength and ductility is possible only when you use a nano length scale reinforcement. You can also put the ceramic particles like boron carbide, and you see here again your ductility is doubled from 6% to 12%. Anything more than 10% is wonderful for a manufacturing engineer. You can give your material a shape that you want to give. Any intricate shape you can give. Compressive properties also increases. So nanoparticles are the one which can give you a simultaneous improvement in the strength and ductility. In the development of the alloys, we developed the alloys like containing zinc, gadolinium, and calcium, and you see the improvement in the properties by almost 3 to 4 times, from 75 to 260 megapascal, 335 to 585 megapascal. In this case, your failure strain reduces but stays beyond 10%, which is a critical requirement of manufacturing engineer. So what is the importance of this value 260, 585? Because now these values exceed certain very high-end commercial alloys used in the aerospace application like WE43. So you can take this composition, build your own alloy. Now you see the magic of nano reinforcement, which is zinc oxide in this case, and now you get the values 355 megapascal, 703 megapascal in UCS, failure strain still remaining 10% and higher. So what is the importance of these numbers here? Now these exceed your commonly used structural mild steel such as 275 and S355. The properties are given here. And you can see that now magnesium can give you almost 75% weight saving. And that is where the whole world is going now. That's where the industry is moving towards. Now, one of the main failure mode when you put a component in the practice is under the cyclic loading or the fatigue failure. So some work was done with Professor Srivatsan in University of Akron, and we worked on AZ31 commercial magnesium alloy reinforced with carbon nanotubes. Of course, the properties, the tensile properties improved with the addition of CNT from 203 to 237. UTS also went up, and the elongation also went up. And if you look at this graph here, stress versus number of cycles to failure, for a given stress, the number of cycles to failure for a composite is always higher. Similar results were obtained for Al2O3 reinforcement. For a given stress level, the number of cycles to failure is higher. Now, the dynamic behavior of the material is important, because when you're driving a car and you meet an accident, then your loading is dynamic loading. So we worked with some people who are expert in the dynamic behavior, and they did it using the split Hopkinson bar. And if you look at this graph here, now you see the black curve correspond to a composite and the blue curve correspond to a non-composite. So under the dynamic loading, your composites have higher strength and higher ductility, all the way from 11 to 33%, depending on the amount of nano reinforcement in there. So what does it mean? Why it is important for the transportation industry? If a material increase in the strength and ductility when it is being impacted or collided with, your probability of the passenger to survive is much higher. So that is why this dynamic testing is important. Sometimes you want to use your material at elevated temperature, and this is where we did some work with ISM Dhanbad with Professor Malik there, and we worked on magnesium yttrium system, and we found that all the temperature till about 250 degrees centigrade, the strength of your nanocomposite remains 1.5 times higher than that of the monolithic material, and the graph shows this relation of the temperature and the strength, where the composite is always superior to that of monolithic material. We also did work for high temperature characterization, which is called the creep failure of material at high temperature, with the researchers Norbert Hort and Hajo Deringer in Germany in Magic Innovation Center, Magnesium Innovation Center. And we gave them a new material containing tin and yttrium. Of course, we found an increase in the hardness, increase in the strength values, as you have seen. And when you convert that into a nanocomposite, the hardness goes up further and the strength goes up further. And this time you are getting a ductility of 27%, which is superior to most of the aluminum alloys that you are aware of. And apparently, and these are all also relatively non-toxic element. And when they did the creep behavior, which is shown by the blue line for composite, nanocomposite material, they're always superior to the monolithic material. So putting a reinforcement or nano reinforcement improved the high temperature response. Now, many of the metallic elements are also used for sliding application. And when you take this commercial magnesium alloy with 1.5% Al2O3 in there, just by putting 1.5%, you increase the sliding resistance by about 25%. And if you compositionally modify it by putting the calcium in there, you get another 25% improvement. So that means your life of the component is now 1.5 times of the original component. That saves on 50% of the component cost. We did some machining studies with the researchers in IIT Delhi with Professor Aravindan. He wanted to inspect the probability of the deep aspect ratio holes, and their finding was that yes, we can drill the deep aspect ratio holes in magnesium. We don't see any abnormal arcing or random spark discharges, and the roughness, surface roughness is also very acceptable. We also send more nanocomposite to University of Newcastle, both in Singapore and UK, and they found that the cutting force for all the nanocomposite remains lower than pure magnesium, except for one composition. The surface roughness is perfect. So basically, it gives you a probability of machining your materials faster without any compromise on the surface characteristics. Now, when you put a material into a form of a component, it is exposed to a dry environment or wet environment. So you have to see the oxidation behavior in the dry condition. Now, if you look at this graph, for example, where we did the oxidation studies on nanocomposites till about 470 degrees centigrade, you see this light blue curve. The weight change is always lesser than the unreinforced material. So putting a reinforcement improves oxidation resistance by reducing the thickness of the oxide layer and making it more compact. And this happens because by putting the reinforcement, you refine the microstructure, and similar studies have been observed by researchers in Australia, where they observed in stainless steel, just by refining the microstructure, you can improve the corrosion resistance of the steels. We also did the corrosion investigation in the wet condition with collaboration with late Professor Balasubramaniam in IIT Kanpur. And he found that the wet corrosion susceptibility of the nanocomposite reduced to 1/3 if you put the nano reinforcement by Al2O3, and he attributed that to the reduction in the cathodic phases, which are responsible for enhanced corrosion. So basically, there's a lot of work done in this area, and in this graph, you see that y-axis is yield strength and the x-axis is ductility, two typical parameters which are used by the mechanical engineers, and it tells you what property you want for your application, what ductility you want for your application. It tells you which reinforcement to put, metallic, hybrid, what processing you have to use, casting type, water metallurgy type, and you can choose your composition. So such bubble charts are available in the open literature. We also did the ignition behavior of the magnesium because the customer often wants to see the ignition response of this thing. And we realized that just by putting a nano reinforcement such as SiO2, you can increase the ignition temperature from 580 to 611, which is about 30 degrees centigrade higher. So notice that magnesium has ignition temperature of 580 degrees centigrade. And here I want to highlight you that all the electronic materials typically melt at maximum 232 degrees centigrade. So if you want to really sabotage a system, you don't have to go for magnesium. You can easily target the electronic system. And we found a very interesting relationship that you can increase the ignition temperature with increasing the amount of reinforcement because they reduce the thermal conductivity. We are also exploring magnesium as a biomaterial for the temporary implant, because remember, magnesium is a nutritional element which our body needs for a good growth of the bones and many other functionalities of the body. And currently, when you have a fracture of the bone or a crack in the bone, you go to the hospital, they put a steel nail in your body, your fracture is healed, then they go ask you for second operation, they take the nails out. Now, what happens if you use the magnesium nails? You have a fracture, you put the magnesium nails in, you seal the body, no problem. Your magnesium will disappear from the body within 1 year after your bone is healed in a few weeks' time. It will give the necessary support. You don't have to go for a second surgery. You save on the doctor's time, you save on your second operation, and you save on the cost that will incur when you go for the second operation. That is why the world is moving in this direction to capture the biomaterial market for magnesium. That is where a lot of research is going on currently, and some products are already coming up in the market. So we worked on some nanocomposites containing titanium, titanium diboride, titanium oxide, titanium carbide, and titanium nitride. We want to see their mechanical properties good or not, whether they can sustain that bone fracture or not. So we found that the strength of the bone is about 149 megapascal, and our maximum strength is much more than that. The ductility is only between 1.07 to 2.1. The ductility is good, so our material is stronger and tougher, and the density of bone is same as that of magnesium. So it is like merged very well with the bone. Compressive properties again were superior to the compressive strength of the bone. You see, it's only 167 megapascal, but the maximum strength that these bioimplants can see is almost double than that. So we did the corrosion rate because once a metal goes in the body, all the material that goes in the body has to go through the corrosion test so that they don't degrade. If they degrade also, the product should not be toxic. So based on the conversation with the surgeons, they need a corrosion rate of less than 0.2 millimeter per year, and all this material shows the corrosion rate of less than 0.1 millimeter per year, and they're taken to the next stage, which is the animal testing now. So this graph shows that not all the amount of reinforcement is suitable to be put in magnesium. For example, if you are using TiO2, you don't want too much of the pH fluctuation. So if I have to use magnesium TiO2 nanocomposite, I will use the one which contains 2.58%. But if I have to use TiC as a nano reinforcement, I will use 2%. And if I have to use TiN as a reinforcement, I will use 2% of it. So some experimentation is required to validate your material, which is the best material for the material. We are also trying to develop materials which are lighter. Now, what you see here is that just by compositional adjustment, your magnesium can almost float in the water. We wanted to pop it out of the surface of the water, but this density is about 1.4 gram per cc, and if we take it too close to 1, it will pop out of the water. So why do you want to go for such lightweight material? Of course, in all the sectors which I have already indicated to you, but you'll be surprised based on the recent research done by Australians. It came only in the last week newspaper. There's a 14 million tons of microplastics litter the ocean. Now, American researchers did some research about 1 year back. They took 8 different people from 8 different geographical locations on the planet Earth. They tested their stools. They let them eat what they want to eat. They want to live anyway, you can live. And in all the cases, they found 10 types of microplastic in their stool. That means a microplastic has already entered our food chain. How it is going to affect the body, we do not know yet, because maybe they have to reach certain level to create serious health effect. So that is where, if you make a magnesium lighter, even lighter, then you can replace plastics in many applications. So that is where we are moving on. So in conclusion, I would like to say that there's a tremendous scope of using magnesium-based materials, including nanocomposite for engineering and biomedical application. You don't need expensive infrastructure. You can use a conventional processing method that you use for aluminum. There's a tremendous scope for engineering and biomedical application. It's just the implant market for temporary implant is $7 billion. If you add up to the automotive sector, aerospace sector, sports sector, maritime sector, it's a $1 trillion industry. And any country which makes a preemptive or they position themselves now are going to gain significantly in materials development, in manufacturing, in many other areas. So the message here is that magnesium technology has arrived. It's a wonderful material, sustainable material, non-toxic material, and it should be used, and the research should go on in that direction. So I conclude my talk with acknowledgement of all my students who have contributed to the work. Thank you very much. And I will stop sharing this one, and I'm open to the question now.
Thank you, sir. It was really an interesting and very introspective kind of a talk on the use of magnesium material. We are really surprised with the scope that we see in this material for future applications. Now I ask the participants if they have any queries with reference to the talk given by sir. It's open up for the discussion.
Maybe the participant can put the question in the chat box, and someone can read it also from there.
Yeah. The participants can also put in their queries in the chat box. We'll wait for a few minutes, sir.
Yeah.
There is a query, sir, from Kiran Chakravartula.
Yeah.
How biocompatible is magnesium inside the human body when it interacts with physiological fluids?
Yeah, it is, as I indicated in the talk, that it is an element which is recognized by the body. It is required almost 400 milligram per day. The maximum is calcium, which is about 600 to 650 milligram per day. So you need magnesium. So anything in excess, first thing, it is non-toxic. Anything in excess, if it goes in there, it will just come out with the urine. So my answer is highly biocompatible.
Yes, sir. Thank you for an answer. I actually wanted to ask, particularly in the context that, like you said, it actually is a nutrient that is required by the human body.
Yes.
So would it not be, I mean, if I implant something or if I want to send something in a, say, some vehicle of magnesium,
Yeah.
would it not be eroded in the process of actually reaching there? And how exactly can we protect it from also the physiological fluids?
You are talking of outside the body now.
No, I'm talking about using magnesium as a nano shell or anything that can probably be
Inside the
used in
body.
high-character drug delivery, for
Yeah.
example.
Okay. See, the thing is that we cannot use magnesium for permanent implant. When I say permanent implant, means a hip implant, knee implant, because it's going to react with the body fluids. So what we are doing is that we control its reactivity. For example, any small cracks to the full fracture, depending on the age of the person and the extent of the injury, can take from 1 to 2 weeks to up to 3 months. So we want to keep it to maximum of 3 months where it maintains its biomechanical integrity. And then it's going to slowly dissolve in the body. So that is the whole purpose. So for any application, if you want to use it, you ensure that it will dissolve over the body. Now, different magnesium-based material will have different dissolution rate. So based on your application, you can choose it or you can tailor it that for how long you want it there. If you want in a form of skeleton or scaffold, for example, for how long you want it to be functional. And then you have to make it using the right composition. Okay, why it was ignored is that it is because the people did not face the global warming. People did not have the issues of the energy shortage. It's only from 1990s that scientists have started realizing that something is not right with the environment, because they found that all these storms, tropical storms, droughts, and everything, the rain patterns, they are changing slowly. So they started recording all the way from 1990. And that is where now the single objective is global warming. Global warming comes from CO2. CO2 comes from the greenhouse gas emission. And you have aerospace industry and automobile industry worldwide increasing at the rate of 25%. When I was growing up, there were hardly any cars on the road. Now every family has a car on the road. So you have seen the exponential growth, and that is where we have seen so much CO2 smog, especially in India. And not only in India, India is only one of the country, but in any country, these kind of things are there. So people have suddenly realized that magnesium is one of the way. Plus, another factor, somewhere in mid of 1990s, people explored and found out lot of reserves of magnesium on this planet. And that was another reason. And they found that if it is so much in there, maybe it can beat aluminum in terms of prices. So it may become economically viable. So that is another reason. Another question is that any idea how it was used as fuel in car? Yes, people are working on magnesium based battery, but that is a totally different application of magnesium. When you want to cut down on the weight of the vehicle, that is where you can make most impact on cutting down on the CO2 gas. Battery concept is totally a different concept in which you eliminate the use of fossil fuel. There is a lot of research in magnesium thing, but it is still far from being applied into the real situation. How we have comparison magnesium alloys with ceruleum. What is ceruleum? May I ask what is ceruleum? Selenium. Oh, selenium is never a structural element. It is an expensive element which is not likely to be used. So remember, the theme is lightweight, and magnesium is a lightweight. So no one beats magnesium in this thing. And always remember, when you choose a material, cost factor is very, very important. If I give you a part which is made of $1,000 versus a part of $100, I'm selling you a bike. Will you buy a bike for $1,000 or for $100? which can do the same function. The idea is that you will buy a cheaper bike if it can be as functional as the other one. So cost factor is extremely important. Magnesium, we are not trapping emission at this point of time. Magnesium is used for minimizing the emission, because if you lightweight your vehicles, you burn less fuel. So for example, if you have a heavy vehicle made of steel, maximum mileage you get is 8 km per liter of petrol. But if you have a same car made of magnesium, you can reach up to 25 to 30 km per liter. So you burn less fuel, you cut down on the CO2 emission. So that is the main objective of how you use magnesium in minimizing the CO2 emission. Now, this question is asked, what Kiran has asked me, some of the household utensils are made of aluminum. Okay. My advice, in fact, when I gave this talk 5 years back in Chennai, many of the housewives met me next year and say that they have thrown all the aluminum utensils and replaced them with the steel utensils or cast iron utensils, or even copper is better. Because aluminum, yes, you can cook, you can do all kind of things, but do not store anything there over the night and everything. Because if you're, say you make curry, say spicy curry, or if you add vinegar and all this thing, there's a likelihood that the aluminum ions can leach into there. And once this damage, and once this aluminum ion accumulates in the body, they may go to the brain. They make the deposit in the brain. And that is the work done way back in 1995 in Australia, when they stopped using the aluminum-based salts for water treatment. It's linked with Alzheimer's there. Now, since body does not recognize aluminum, they don't know how to throw it out. And there comes a problem. So over the time when you grow up, then you will start seeing that your renal function is not working. You start to forget many things, dementia, Alzheimer's disease, and all these things. One of the cause, I will not say the only cause, one of the cause is the presence of aluminum in the body. So if possible, try to avoid it. Don't store your things overnight or something like that. If you really want to cook it, aluminum has a wonderful oxidation resistance, cook it, but remove it as soon as you can. And the best solution is replace aluminum utensils, especially for cooking when the temperatures can be high, acidity or alkalinity can be high in your food. So do that. Okay, what other question? There was a question by Professor Padma. What was that question?
That's about the utensils, sir.
Yeah, Padma Shri, some of the household utensils. Yeah, okay. So I've answered that question. Okay, okay. Yeah.
One more question that is missed out.
What is the other question which I missed?
Can we compare magnesium alloys with titanium niobium alloy as bio-implant application? This was asked by Dr. Srinivas Gupta, our HOD.
Yeah, niobium don't use niobium and cobalt chromium and all this thing. We have seen a lot of lawsuits for the hip implants because both cobalt and chromium are toxic to the body. They are very damaging. I really don't know how they got approved by FDA in USA to start with and marketed by Johnson & Johnson, DPI. Don't use it. Titanium, you use it only if you're targeting the permanent implant. Titanium does not dissolve in the body. If you use, for example, I'll cite you an example from Japan. When they do the operation, they open up the body and they have to stop the blood flow. They use the titanium clips. When they use the titanium clips, I ask them how many used. They say for a big operation, 50 to 100 clips are used. And once the operation is done, they seal it. So what happens to the titanium clips? They don't react. They're bioinert. And they stay in the body for the rest of your life. So every time you go to the airport, your siren is going to sound. But instead, now they are developing the magnesium clips. So now you use the magnesium clips. The job is done in 5 to 7 days of stopping the blood supply and ensuring that body heals up. And within a year, you are metal free because magnesium clips slowly dissolve away, go away. So that is where you are.
Sir, one of the advantages what we have seen in recent findings that titanium niobium alloy exhibits less elastic modulus, so that is very much compatible for bioimplants are considered compared to titanium and alloys.
Yeah.
what was before people using.
But the cost of that is very high and it is a permanent situation. So we are using magnesium not for permanent situation, we are using for temporary situation. Second thing, if you look at the cost between the two, you will see a 1:5 difference. So you have to look from the cost point of view also.
Achha, achha. Okay. Thank you, sir.
Yeah. Any other question I will like to welcome, because one of the objective of the conference is to share the knowledge.
Yeah, one more question that is missed out. It was asked by Dr. K. Anuradha, Dean Academics.
Yes.
In elderly people, sodium, potassium, and magnesium components play vital role.
Yes.
How to maintain the levels?
Well, that is a biological question. Well, that I cannot answer. I think the best thing is to have a balanced diet in that. But you'll be surprised that many of the people in India, we do lack in magnesium intake. So it's very useful, especially when you're young. Your body can take everything, but when you're not young, I think it is good to have the magnesium supplements. It's as I've shown in the slide, it is so useful in so many things like cardiovascular system, your immunity system, your sleeping patterns, your bone health, and so many things. Many of us are not aware of it. What we are aware, because I'm grown up in India, we are aware of iron deficiency, we are aware of calcium deficiency, but that's all we know. We don't know about magnesium as much. So just have a balanced diet.
I think that's like we have no more questions. Thank you, sir. Thank you very much.
Pleasure.
We thank you for accepting our request and then presenting this enlightening and a very inspiring talk on the future prospects and applications of magnesium material in various sectors. Thank you very much, sir.
My pleasure. And I would like to share that I have also proposed that I talked with the director that we have also proposed this direction to the Prime Minister office here for their ongoing web of conference. So you may expect a lot of funding may be coming in the near future on magnesium based material in India. So I just want to share it.
Yeah. Thank you, sir.
Yeah. So can I take off now?
Yes, sir. Yes.
Okay. Thank you, everyone. It was a pleasure.
Thank you. Now we will move on to the next keynote lecture. So I will introduce the next speaker. We have Dr. L. Sivaram Krishna, Associate Professor, Department of Mechanical Engineering, University College of Engineering, Osmania University with us. And he will be presenting the keynote lecture on the sustainability aspects of 3D printing through various case studies. So I would like to introduce the speaker now. Dr. L. Sivaram Krishna is working as Joint Director, Center for Product Design, Development and Additive Manufacturing, a center of excellence established under RUSA 2.0. Nodal Officer, PM SSS J&K, then single point of contact for local chapters Swayam NPTEL, as well as the NSS Program Officer and Faculty as well advisor for YUMMI course on DFM. He has also worked as Joint Director of Evaluation Examination Cell, University College of Engineering, Osmania University. His areas of research interest include 3D printing, CAD/CAM, computer integrated manufacturing, and cloud-based manufacturing systems. He has published 80 research papers at various referred international and national journals and conferences. He has visited various foreign universities, to name a few: Florida International University, Miami, USA, Tesserae University, United Kingdom. He is also the reviewer for many reputed journals like Institute of Engineers India Series C, British Journal of Medicine and Medical Research, etc. He has won the Best Research Paper Award in the International Conference on Recent Innovations in Engineering and Technology at Bhubaneswar. He is also the editorial board member of the International Journal of Engineering Technology and Advanced Engineering Journal. He has authored a textbook on production technology. He is also the doctoral committee member of VIT University, Vellore, and also member board of studies for various engineering colleges. He has guided more than 60 ME projects and presently guiding 9 PhD scholars. He has delivered 75 guest lectures in various UGC and AIST refresher courses, webinars, etc. He has also organized various STTPs, conferences, workshops, etc. He has organized prestigious program Global Initiative for Academic Networking GIAN with Professor Suman Das from Georgia Institute of Technology, USA as the research person. He has also done many research and consultancy projects in the area of 3D printing. So I request now Dr. Sivaram Krishna sir to please start the keynote lecture.
Yeah, thank you very much, sir, for your nice introduction. And I would also like to thank the coordinator of this program, Shivraj Garu, and the head of the department, Gupta sir, and the organizing committee of this conference for inviting me as a keynote speaker for this international conference organized by your prestigious VNR Vignan Jyoti Institute of Technology. I also like to thank the management for giving me the opportunity to share what are the experiences I gained when I started working 3D printing for the past 10 years. And here I am going to present, as I was telling, on sustainability aspect. Actually, I have my paper presenting in the same conference on sustainability aspects. So I will be basically presenting now what are the innovative applications of 3D printing, and that I'll be presenting in the given time period. Sir, my screen is visible, sir? Is my screen visible, sir?
Yes,
Hello?
sir. It is visible.
Yeah. So basically, I am going to talk about how 3D printing can be used for a different application which you never expected. And as Professor Shivraj sir was telling, how 3D printing can relate to sustainability. Definitely, because 3D printing is called additive manufacturing or positive manufacturing, where you don't remove material. So the material wastage is less when compared with the conventional manufacturing like CNC and other aspects. So here we'll be basically, we can reuse the material also. The unused one, we can reuse it. So in that way, we can say you are nearer to the sustainability. Actually, we have made compared a study between the additive manufacturing and CNC for two applications. One is for gear and other one is a PCB for a missile component, which I will be presenting in my paper presentation. And we have found that using 3D printing, the sustainability is better than the case of your CNC machining process in various aspects, right? So that I will be presenting during my paper presentation. So let us see what you are seeing on the screen is how can an engineer can help a society by working with a doctor. That I want to present through live case studies that we have done over the past years. Here, for time limit, I'll be presenting 3 case studies, how we use 3D printing for biomedical applications. Like you are seeing on the screen, the left side top corner, you see a injury on the skull. So how you are going to develop an implant with the help of a 3D printing process. That I am going to present a case study. It's called cranioplasty operation. Similarly, you can see how 3D printing can be used for your aerospace applications, like for your a CubeSat satellite, which we have made for small satellite using entire 3D printing technology, or how NASA is using its rovers for next expedition to Mars, where they will be taking the rover to the astronauts to the Mars for conducting the various experiments, and how 3D printing is helpful in making this rover. You can also see how 3D printing is now is used in entertainment industry, like movie making industry, especially when you see a lot of Hollywood films, they use 3D printing technology for various applications that I am going to show here. You can also see how 3D printing can be used for sports industry, especially you can see the shoe or a cricket, everything, how the 3D printing technology is used there for making various products. And applications of 3D printing on architecture, on jewelry, and on interior decoration. Even in interior decoration of 3D printing is coming into a huge application. In food processing industry also 3D printing is used, because sustainability talks about how you protect the environment, at the same time you try to give the best products. So here 3D printing can be used for even food processing industry and electronic industry. So in my presentation, I'll be concentrating on these fields: biomedical fields, aerospace, sports, entertainment, food processing, jewelry and electronic industry, apart from the interior decoration and construction industry. Actually, I would like to say that we have a Center for Product Design Development Additive Manufacturing, Usman University, where we have the start of the state-of-the-art technology like selective laser melting, metal 3D printing, SLS, SLA, DLP, Polyjet, Ultimaker S5 Pro, all these things. They are Arctic 3D scanner, which is related to entire, you can say, starting, if we bring a product also, we can scan it and develop a new product to you. And we are offer this one for BE, ME and MTech students. Also, you can do research works. This is led by Professor Sriram Venkatesh, Controller of Examination. Myself is the Joint Director, right? So let us understand what is 3D printing. I hope all of you know the definition, most of you. It's also known as additive manufacturing, where you create from a CAD model directly the product without developing any part-specific drawings or toolings, etc. And you straight away draw the take the CAD model. Either you draw it from scratch or you develop it reverse the existing model. You can scan it, or you are doing a biomedical application. You can do a CT MRI scan and develop the CAD model from which you produce the final product without using any tooling or any kind of programming, part specific tooling or programming, and very less human intervention when compared with the CNC programming. And it is known by different names like additive manufacturing or layer manufacturing or free from manufacturing, or it is also called direct digital fabrication process. So it is one of the thrust areas as per AICT and as per the DST also, where the next manufacturing process is going to be most adopted is 3D printing technology, and it also comes under Industry 4.0. If you see what are the basic steps in any 3D printing technology, so there are 5 steps involved basically. You see, you first develop the CAD model. CAD model you have to develop from scratch, either from using your Creo or SolidWorks, any of those softwares, and or you can develop from scanning the existing product. But the most important step in the entire 3D process is the CAD modeling. If the CAD modeling is not correct, the final product will be a failure. It's like garbage in, garbage out. So in a computer programming also use the term, if the input is not correct, output will be definitely wrong. So you cannot blame the 3D printer for the mistake, but the way you designed it, you modeled it, there you might have committed some mistake. So this is the most important crucial step in 3D printing process. So you develop a CAD model using 3D print technology. Then once you develop it, then you convert it in one file format called STL file format. That is triangulation, you do it. So once you develop the triangulation, then you transmit to the computer which is nearer to your machine, and where you remove any errors existing in that one using or different softwares. Because when you convert a regular object into a STL file, definitely STL file is in the form of triangles, straight edges. Wherever you have a curved one, there will be some gap between the straight edge and the curved one. So that gap you have to remove. So that errors you have to remove. Once you remove the error, prepare it, then you send it to the machine where you build the part. Once you build the part, then you do the post processing. Post processing may be a curing operation, or you may doing a cleaning, like removing the supports, or if it's a liquid based technology, then you have to cure that one in the oven. Or if you are using a powder based one, you have to remove the unused powder which will be adhering to the product with the like a coating. So you have to do air blasting or improve the strength, or you may go for sand blasting, or you may as well as go for painting also, depending on requirement. These are the post processing process. So basically any 3D printing technology uses these 5 steps. But now I am not going in detail about the fundamental 3D printing, because that is not my topic. I am going to present how this technology can be used for biomedical field. Let me talk. So here I am going to present 3 case studies. One is on cranioplasty surgery, and other on facial asymmetry and facial reconstruction, how 3D printing can be used. And these are the live case studies which we have worked with the doctors in Hyderabad and solved these interesting cases, right? So before that, let us see, as you know, the doctor engineer, when they both join hands, originally you became a doctor because they are very good in BPC, you became an engineer because very good in maths. But when you both join together, you are going to solve some very interesting case studies. Your contribution to society is immense. That's where you say 3D printing is also sustainable, because sustainability is something which helps human being life, which helps the human being have a good life together. So how 3D printing can help out in sustainability of human life. So that's how I can say this technology is very helpful to the human beings, especially in biomedical application. 3D printing became very popular, especially like surgeries like orthopedic, and dental, and as well as maxillofacial surgeries. And all this application of 3D printing is coming up large. In future, you may see bioprinted organs also, that is still in the research stage, but in future it will be coming in a altogether a different fashion. Why it is very popular in medical application? Because in medical application, for example, imagine the patient is shown X-ray. For example, there is a fracture to the patient, and the doctor advised to take an X-ray or CT scan. Once you take the X-ray or CT scan, and the doctor tries to explain that X-ray or CT scan to the patient, definitely the patient will not be able to understand. I hope most of us also have got that experience. Will not be understanding what doctor is telling. You'll be showing some image and explaining, because it is a 2D image, you cannot get it. But if you got a 3D model with you, educating the patient becomes very easy for the doctor. So that is how you communicate to the patient. 3D printing helps the doctor in communicating to the patient, because the patient is shown exactly what happened. You will also know that doctor is going the right direction. You build a confidence in the patient. That is the most important thing. Next one is the doctor also can do diagnosis and surgical planning. Before he performs the operation, he can plan his surgery, and as well as he can do rehearsal and simulate on the mock-up models. He can practice everything on the mock-up models once he does. And he can also help in developing customized prosthetics, because now without 3D printing, with the help of CNC and other application, what is happening is you are making a generic prosthetics which may not suit exactly to that person. But as per using 3D printing, you can make customized implants and prosthetics which will help in more comfort to the patient. That's what you can do it. And you can also develop accurate placements of implants also. That is helpful. So it will help doctor in planning, preparing, and practicing the surgery. What transformation you can bring for 3D printing is from a 2D to a 3D model you can develop using 3D printing technology, right? So there are different applications of 3D printing in biomedical application, like orthopedic implants, like human anatomy, surgical aids. In all these applications, you can use 3D printing. And especially in tissue engineering, scaffold support structures also you can develop using 3D print technology. Imagine that you want to grow a support structure in your human body, you want to grow an implant in your human body, you require some support structure for the implant to grow. So that support structure is maybe a complex support structure which you can produce using 3D print technology. You can also print organs like ear, like your trachea from stem cells. You can develop artificial skin or printed kidney or artificial bladder. All of them are coming up shortly, but it is still taking time to get the what you call the biocompatible and all other ethical issues, etc. Once this is clear, I hope in few years we can also see bioprinted organs, etc. That may be also coming in next 5 to 10 years. What are the materials that are biocompatible? Are stainless steel, titanium, polymethyl methacrylate, PEEK, polyether ether ketone, calcium hydroxide, and one form of ABS, that is ABS M30. These are some of the applications, some of the materials which are compatible and used in implants, and these are the materials which are used by 3D print technology also, right? So let us see what is the procedure for creating a medical model. So first you have to ask the CT or MRI scan DICOM format from the patient. Once you take the CT or MRI scan, then you capture it. From that scan you get the CT scan data. Then using a medical imaging software like Mimix or 3D Doctor, you develop the CAD model. Once you develop the CAD model, then convert into the STL file. So once you convert into the STL file, then you can send it to the your machine which builds the parts. So that is the post processing. You do it. Once the part is built, you do post processing, you get the finished model. So these are the general steps involved in biomedical modeling. So the important input in biomedical modeling is the DICOM format. That is, you have to ask the doctor or the radiologist to give the CT or MRI scan the DICOM, which is nothing but digital image and communication medicine. If you take this in this format, then you get the exact one. And what is the role of different things people involved in this process is for data acquisition. You take input from the patient using a tomography instrument like CT scan. You get the image. Then you develop the virtual model. That is from the CT image input. You develop the CAD model of it using a dedicated software like a 3D Doctor or Mimix or Invasilus. All these things are 3D slicer you can use and develop the model. There your role is there as a computer graphic expert working with the surgeon. Everywhere in this, surgeon is with you in authenticating your work, in validating your work. Once you develop the CAD model, then you can develop the 3D physical model. Physical model you can develop. You may use different technologies depending on the application. You may go for stereolithography or FDM, any other test step. Once you develop the model, that should be again validated. If it is okay, you go for virtual surgical planning procedure, or otherwise you go back and again redo your CAD model and do the steps, repeat the steps. And once you do your virtual surgical planning is over, then you validate your planning process. In here also surgeon is there. So in the CAD model, if any error in any iteration you have to do, again you have to help the doctor in modifying your CAD model. Once you do the surgery, then you, what are the virtual surgical planning you've done? Once you perform the mock surgery on these models, you say it's okay, then go ahead with the actual surgical operation. Otherwise, you go back and remodel it. So these are the role where you are involved as an engineer in helping the doctor in making that operation successful. But the most important step is how you develop the CAD model from the your image, basic DICOM image. So what you have to do is, once you take the DICOM image, because whenever you capture the CT scan image, and my interest is to develop an implant for the skull which has broken. That means you develop a bone. You are concentrating on the bone. But when you take the CT scan image, along with the bone, you are getting soft tissue like skin, other things also. Now, in your image, you have to remove those things and get only bone structure, which are how to get that one. So that can be done only through a thing called thresholding. This in any image processing software, you have a threshold value. What is threshold value? Is whenever you take an image, there is an pixels, it will be converted in the pixel form. So each one has got its own pixel value. Skin has got some pixel value, and your bone has got some other thing. And each one, if you select that value, you'll get skin from the image. If you select that value, you get a bone. That value is called threshold value. So you should be very careful what is your region of interest. So based on your region of interest, you have to select the threshold value. Once you select the threshold value, you get the required one. That is, you get then you remove unnecessary things, segmentation, everything. Then you grow the region where you want to develop the implant, and finally you develop the product. So generally threshold is measured in Hounsfield units. That is done here, right? So this what you do. You take what the workflow is. You take the DICOM file and then you input into your software. It may be any of your medical imaging software like Mimix or Invasilus, or it may be a 3D Doctor. Any of these softwares you can use, and you can see whenever you import it, on the screen you see three regions. What you in medical term it is called, like in our engineering we call front view, top view, side view. In medical term also they call axial, sagittal, and coronal. So these are the three regions you get. So you can see here the bright region. This is a green color you are seeing. This is generally bone has got higher brightness. So that's why this is a bone while. So here I am doing in the software, I am selecting my threshold bone. You can see my cursor. I am selecting the range from 226 to 3071. So this will be highlighted. Remaining portion of this image will not be highlighted. So I am interested only in these three things, right? So this is my region of interest. Once I select the threshold value from year to year, I will get this is my threshold value I've selected. Then once I do cropping and everything, this is the area where I want to do my planning of the surgery or perform a mock planning or develop an implant for that. Once I do it, see, this is how I get this actual one from the image. This is called skull surface will be generated as per. This is my region of interest. So I have removed other things. That is, I remove segmentation, everything. So this is the important step in any 3D printing technology. Now, coming here, so coming to your conference like sustainability. So I am going to tell how this sustainability is a concept is very useful here also is, because in all these cases, what you are seeing on the screen is, I am doing all these things without the involvement of the patient. Involvement of the patient is only there in getting the image from him. Later, patient is not there with me. I am doing everything, this planning, everything I am doing without the help of the patient. I am doing on a computer screen, developing a CAD model. And here what happened, the patient suffering is reduced. I am going to show how patient suffering is going to reduce using with a case study, how it is reduced, right? So that's how you are helping the what you call the patient in keeping away from the agony of whenever anything happens to a person, they get feared about the treatment process, because treatment takes a lot of problem for him, and it creates inconvenience to the patient. So that process we are avoiding here using 3D printing technology, right? that I am going to show with an example. Once you get it, then you develop the STL, develop the model. So this what I am telling, this is a basic step in any 3D doing biomedical modeling. So if you are not doing this correctly, then definitely the part that you get out will not be correct. So as I said in the beginning, developing model is very important 3D print technology, right? So let us see with the help of this case study how we solve the cranioplasty surgery. This work we have done live case study for a person who is 16 years old patient who got injured on his left parietal region of the skull. I got the opportunity to present this in Miami International Conference in Florida, so which got very good reviews for this paper. So generally, what is cranioplasty is a defined a neurosurgical procedure to cover an injured bone in the skull. So in cranioplasty, the most challenging task is not only developing implant, but that implant should not affect the aesthetic of the person. That means, for example, you are developing, there's a fracture on the right side, and you are developing an implant. That implant, when you fix it, it should appear like a natural one. It should not go down or upwards, projecting upwards. So whenever the patient sees sees his face on the screen, you should not feel what doctor is, even though implant is fixed, but still see when I see my face on the screen, it is not looking good. The aesthetic sense, that is most important in cranioplasty surgery. So here 3D printing helps in developing that accurate implant, right? So let us see here. Is a patient who got injured on the left parietal region. You can see under this there is a brain, and you can see they simply stitched the skin on this one and they fixed one, right? So below there is a brain, and the problem is this guy cannot go out until unless you develop an implant and fix it. So this patient came to Hyderabad Care Banjara Hills Hospital. Dr. Satish approached us in how, sir, can you help us in solving this with the help of 3D print technology? This I am talking around almost 8-9 years back. This work we have done. So the thing is, we don't have any direct implant production in our college. We have a SLS technology. Using SLS technology, you can develop a pattern of the implant. Using the pattern of this implant, then you can go for indirect method. That means using the pattern, you can make a mold. In that mold, you can pour a biocompatible material like polymethyl methacrylate and develop the implant. So that's what you can do here. So I asked doctor, sir, how you are going to perform this operation without 3D printing? I asked him what you do. So he said, no, without 3D printing, what they used to do is to get that impression of the implant, they used to make the patient to sit in the operation theater, remove his hair, and put the algae on it. That is a plaster of Paris on his head and a basket, and the doctor used to press on it slightly and find out the impression of it. And here, what happens here is it all depends on the skill set of the doctor, how best you are experienced in doing such type of operation. And other thing is the patient is made to sit in the operation theater for 6 to 8 hours. Here you are actually not performing any operation, only to get the impression of it you are using this. But using 3D technology here, this step is avoided complete. That's what I told the sustainability here. The patient suffering, because sustainability always concentrate how best you don't damage the other things, right? Here I am not affecting the patient. I am not making the patient to go a trauma of getting all this treatment. So in my case, this step is avoided. This is taking at least 6 to 8 hours. Now this is avoided, and simply I am taking CT scan image and then developing the implant. So here in this step, what is the conventional method is the prosthetic sword obtained can be checked for fit only during the surgery. Needs trial and error procedure to achieve good fit for the implant and better implant stability. Excess material has to be trimmed during the surgery. These all happen during the surgery, which leads to utilization of more surgical time, contamination of the field, and possible rejection of the process later. This all happens in the regular kind of conventional method of doing the implant cranioplasty surgery. But now what we have done, we ask a doctor to give the CT scan image. Then using the CT scan image, we develop the CAD model as explained earlier by me, thresholding everything we have put, and segmentation, mirroring everything we have done, and we developed this model. And using the doctor thought using this 3D model, like in place of human head, he will put the skull and put again the algae on it and get the impression. But I told the cost of this model of the skull is around 45 to 50,000 rupees, because my SLS each kg will cost around 5,000 rupees. But investing 50,000 rupees on a mock model, no one will appreciate, and the patient will not be happy with that. So doctor said, sir, can you, we told him, actually you require only this portion. So we can get only this portion. You don't require this. We can get exactly this one. So What you have done, we have mirrored this one using our CAD knowledge. We mirrored this side to this, imagining the both are similar. When we mirrored it, we got this part and we exploded that, and we got this is the shape of the implant that you required to make. This is a CAD model we got. You can see this is not a regular like a circular regular object, regular shape. It is a different shape, and also the thickness also varies from one region to other region, right? So based on this, we developed the using our 3D print technology. We even actually before the operation part, we superimpose that one onto the portion, the implant, and shown doctor how it looks before the operation itself. So earlier conventional case, doctor will know this only during the operation. Now before operation itself, we are telling doctor how it looks, the implant once you fix it. So he was very happy. He said, you go ahead. Then we made this portion of the implant using our SLS technology, forming a P100. Imagine this is not a final implant. We made a pattern of the implant. That's what I want to highlight here. We did not make the direct implant. We made a pattern of the implant. I am doing indirect way of indirect rapid tooling, you call it as. We have done that, and using we produce using SLS technology this model of the implant. And once this is obtained, doctor has taken this and prepared a mold, and in that mold they used biocompatible metal polymethyl methacrylate and developed the actual implant, and that was fixed to the patient. And here you can see it is fixed with the help of a titanium mini plates they used and fixed it here. So you can see we are given a gap between the actual bone and this one. So you can now find out that this is very important, because when you develop, you should ask doctor how much should be the gap you should give, because the bone grows, it should not again appear exert another force on this implant. So you can do a lot of studies on this. As I said, my mechanical domain knowledge, I am using it for a biomedical application, and the result of this is I am saving a patient from the agony and from the developing an implant which is very complex in a conventional method. So this is how we have done it, fixed it, and he was very happy. We reduced the time by 22%. This is what we can achieve using this 3D print technology. This is what the certificate we got in 2013 from Care Banjara Hills. And later we have done a lot of such type of operations with, you can imagine the complexity of fracture here, and both sides you got fractured, and we have done using this command like crop and edit mask and sketching a curve and all those things, mid plane. So all our CAD knowledge we used in developing the implant, and with Yashoda also worked and developed such type of even recently also we done with Yashoda also. So we have done so many operations for this solving this cranioplasty surgeries for, right? So you can develop the processes. So that's how you can use it. This is the application of 3D printing for cranioplasty. Similarly, we have done recently with Sunshine Hospitals facial asymmetry surgery. What is this facial asymmetry? You can see this girl has lower mandible, that is jaw. You can say mandible or lower jaw. It got displaced, and she is not happy with that. She is not happy with that, and she want get it rectified. So she approached the Dr. Suresh from Sunshine Hospital, Secunderabad, and he approached us, sir, can you solve it with the help of the 3D print technology, right? So actually, what is facial asymmetry? Everyone has got facial asymmetry. For example, if you see your face, left and right regions will be like this. But if you try to superimpose left to left, you will look like this. If you superimpose right to right, you look like this. For example, you see Einstein. You can see Einstein. It actually looks like this. But if I superimpose left to left, it will look like this. Right to right, it will look like this. But actually, is looking like this. So everyone has got asymmetry, but the amount of asymmetry is negligible. No one can notice. But in the above case, which I shown the case study, that is noticeable. So you have to rectify that error. So again, we asked doctor how you used to perform without 3D printing. He used to adopt a conventional method called cephalogram. What is this cephalogram method? So they will take a X-ray of the person in different angles, like front view, top view, like we have. They also have different angles, like and then once they take this X-ray in different angles, now every human body has got, each region has got called landmark points. So this is known to the doctor only. So what they will do is they'll put a trace paper on the X-ray, and they know the landmark points, and they find out deviation from these landmark points on the X-ray on the trace. It's a trace paper like this. They put the trace paper on the X-ray, and they locate the landmark points, and they remove the trace paper, and from that trace paper they measure the distances between the landmark points, from which they find the deviation. But what the trouble in this is a 2D image. Actually, one body is a 3D image, right? 3D part. So it is they take different different views, and each different view they calculate these deviations, and each one you are taking from 2D. So definitely the result will not be accurate. So what doctor will imagine with this conventional method is, after doing all these different views, you will get some deviation. So you will imagine that, and you will start going for the operation. Once you opens during the operation, whatever you assumed in 2D may not be exactly there on the 3D object, on your exact human body. So there will the doctor will struggle again readjusting it. So with conventional method for this operation, he was taking around 6.5 hours. But with the help of 3D printing, what we have done, you asked the again doctor to give the DICOM format, the CT scan. We developed the model of that entire thing, and we produce using our flash force printer. We produce the FDM printer. We produce this model. These are the support structures you can see. Once we produced it, we shown to doctor how is the deviation on this. So in the directly on the 3D model, he is able to gauge how much is the deviation. So instead of doing a 2D, you are able to measure the dimension directly from 3D model. And on this, he planned his surgery, how much he has to shift directly. So immediately performed the operation, and he removed that. And this is the transformation we brought before surgery and after surgery. So you can see how is the transformation to the patient. So this is how you can help 3D printing for this facial asymmetry. Similarly, facial reconstruction, like this particular patient also has got some kind of left side, you got cancerous formed on this left side. Cancer has eaten away his bone, and the doctor has to perform this operation. So earlier operation we reduced from 6.5 hours to 3 hours. 3 hours we made. So it's a 50% reduction in the operation time, and the doctor and the patient both were happy, and the accuracy is very good. So similar in facial reconstruction also, this is my region of interest. So we have taken the DICOM format. As usual, is a patient suffering, 23 years old person, and he got osteolytic lesion, and he got this amyloblastoma. Biopsy confirms amyloblastoma. This is the cancer, rare benignant cancer you get here because of pan, gutka, everything. So that may be the result. So what the doctor has to, we develop this one, the image, and you can see here how the bone was eaten away by the cancer. Now the doctor has to put a titanium plate here. So to put this titanium plate, he has to bend the plate. So how to bend? Because earlier he is having a swelling here. So now doctor, what we told doctor is, this side there is no effect on this side. We will mirror this one to the right side, and imagine there is no cancerous tumor, and we develop this mandible. So we developed this portion of the mandible, and with mirroring this unaffected area to the affected area, we develop the mandible, and using this plates, he has bent that directly on that mandible. He has planned the surgery directly, and then we went ahead with the operation, and he was fixed it, and it was very successful. This is how the operation was done during the theater. It was fixed, and finally this is the tumor that was removed, and we fixed it to the patient. This is the transformation we brought using 3D print technology, biomedical applications. So, sir, queries can be asked at the later, or shall I proceed? Any questions from the audience? Hello?
Yeah,
Any
please proceed. You can complete. Okay.
Yeah, right. So this for aerospace applications, as I said, we can use for developing the CubeSat satellites. ISRO launches so many satellites at a time. So when they launch satellites, most of the satellites are of CubeSat. That is, they do some specific operations only. So that size will be very small, and they put all the printed circuit boards on this and fix it and right. So you can make the such type of complex small satellites, everything using 3D print technology. I got the chance to present in Sriharikota in 2016 international conference. So this we taken the CubeSat specifications, and then we produce the part using we selected, there are different structures you can select. We have selected the pumpkin structure, and we produce the CubeSat, and using our CAD modeling we have done it. And finally, using Ultimaker, we produce the entire structure of the CubeSat. So this is a can be used in application, but only you should take care is aerospace, something specific on outer space. The properties are different. That we are not taken. Definitely, we can incorporate that and make a better satellites using this technology. Similarly, NASA uses this for making its next rover. desert rats it is called. They already developed this model, and they're testing in the Arizona deserts how this model can be used. And this, what is the challenge in this is this big, it's like a SUV. You have to lift this to Mars. Mars is around, it will take 1 year to travel to Mars. So the weight of the vehicle should come down as far as possible. So they produced, using statistics machine, they produce 70 FDM parts out of this using 3D print technology. So which is used in this rover aircraft. I am going to show small video on this, how this technology can be adopted. It's a small video. So this is the vehicle they're developing. They're already testing, and so in this vehicle, they're actually developing this entire door is made using 3D print technology. So they carry 2 astronauts in this vehicle. So the AC ducts and all the parts they produce using statistics FDM technology. I am, because the audio may not be audible to you, so just because. So this is the FDM produced. These parts are all produced using FDM technology. This entire door uses 3D print technology. Even the electronic controls, the cabins, all these things are produced using FDM technology. So this is how NASA used this FDM for making this rover to the Mars. Similarly, our India also in Tejas aircraft, they used 2,500 parts with cover engine. They used the FDM technology for producing all these parts. And this huge Chandrasekhar and GTR is there in this project. And what they have done is they reduced the cost of the product from 60,000 to 20,000, and the time of producing them reduced from 12 months to 1.5 months. That's how the saving they brought. This is what you can sustainability. You are reducing the time to manufacture, means your effect on the environment also comes down. So if you do LCA live cycle assessment analysis, this is how it helps in reducing the effect on the environment. Similarly, the rover which was sent to Mars for getting the data also made using 3D printing. All the parts of the rover are made using FDM 3D technology. So they are assembled everything. So using Ultimaker, they produce the parts. Now let us see how it can be used in sports industry. As you can see, the shoes are the shoes worn by the sports person or the athletic, etc. Or you can nowadays, this wicket system is becoming popular. I hope now all of you are watching IPL matches. You see what type of wicket system that is used. That is called zinc wicket system, where you are putting LED inside this stumps and also in the bails. So it has got two purposes. It will give good technical decision making help to the umpire. So when he makes the decision whether exactly is run out or anything happened. At the same time, for spectator also in a day and night match, you see this glowing bales lifting away, and it brings some kind of aesthetic sense to the patient. So both way it helped. Actually, this type of wicket system was introduced in Australian domestic cricket in 2015. Later, it became popular in the World Cup. Now it is adopted in every format of the cricket, either T20 or One Day International or Test match. These stumps are become default. That's why they are costlier. Now the winning captain is not allowed to take these stumps. So this is used. This is developed by the Australian mechanical engineer. His name is Bront Eckerman. He used this technology for producing these stumps. Right. Similarly, sir, any? Yeah. Similarly, Reebok is developing its new shoes called Reebok Liquid Speed. This shoes is designed for distance running, cardio workouts, and comforts. You can see the outer sole of this. You can observe my cursor. Outer sole of this shoes is made using this. They developed particular 3D printing technology, which I'll show it to you. And they produce this outer sole, which will fix with your lace. So what happens is whenever the athletic runs or the sprinter runs, no, this outer sole will help in cushioning the athletic and also giving bounce back. So you will not feel you will feel more faster to run, and also it will help him in reducing his strain on the legs. That's how they use the urethane based liquid that was used to produce this outer sole. And now not only this Reebok, but every big companies like Adidas, everyone are using this technology. Let us see this small video on how Reebok uses this technology. Earlier, they were using molding technology for making all the shoes. That's why I'm telling innovative application of 3D printing, because you never imagine your technology can be used in different fields. So only the thing is you should have the thought or the idea, then you can think about 3D printing for making innovative things. So this is how you can see. So this like a robotic arm is an extrusion process, and they're producing this liquid based urethane. They're depositing and getting the outer sole. They integrate with the lace your outer sole. So they are putting high energy material inside this. So it has got twice the energy return when compared with conventional rubber. And producing this is conventional method is very difficult. But in 3D printing, you are able to produce. That's why all these big company shoes are costlier when compared with the conventional one. You see how it is helping the athletic to run faster. So you can see Adidas, Nike, Under Armour, New Balance, everyone is using this technology for developing different parts of the shoes. Like Adidas uses direct laser sintering technology using polyurethane metal. They develop midsoles, uppers, and other parts of the soles. Soles like Nike also uses selective laser sintering, and Under Armour uses SLS, and New Balance uses SLA stereolithography, and Reebok uses material extrusion liquid, which is their own technology they developed for producing different parts of the shoes. So even the entertainment industry starts using all Hollywood films. You can see they are using this technology a lot for producing different types of figurines, or you can call props, or the dummy weapons they use in the screen, because nowadays the film industry is also very huge marketing revenue generation industry. And in all the films the screenplay is great nowadays. The technological advances which is emerging for the spectator, that will draw him to the theater to see that film. So how can you achieve that? How can you make the audience to come to your theater and watch your film? Because only if you produce something very different, which is not imaginable conventionally. So like this weapon what you are seeing, this type of model you can produce using 3D printing very easily. So I am going to show how all these Hollywood films like Lord of Rings, Iron Man, and the Spiderwick, or you can see the Pacific Rim or Jurassic Park. All these big films of Hollywood, they have taken help of 3D printing, and there is one studio called Legacy Studio, which will use this technology a lot in producing that special effects. Right. So let us watch this film, this small video on how. They use FDM technologies. They also use the Object Pro liquid-based technologies for making various parts of this movies. I say only if you are very good in 3D printing, why can't you think about joining this industry also? You can develop new models, which is very challenging for you if you are having a very creative mind, because film industry is a creative industry. So you have a technology. See how many engineers works here. The studio we started with by 4 engineers: electronic, in mechanical, a what you call a design engineers, and also what you call a graphics person. All these people joined and started this legacy studio where a lot of engineers will work. Electronics department also works here. This, it's like a regular manufacturing industry, but you are doing for a creative field. For example, I want to show here, you see on the screen there's a big war like Lord of Rings or some other movie. So actually what they do is they take who are participating in this war, the actors, they'll scan the actor completely, his face, everything, and they produce a miniature image that's called figurines. They produce miniature image with corresponding action scene on the field. For example, she is being hit by this person. So this is the scene. They make a small figurine using 3D printing. So imagine making such complex objects using the conventional method is very difficult, time consuming, and also a lot of material wastage. But using 3D printing, you can produce in no time. Only your CAD modeling should be good. Once you produce, this will exactly look like the original person because you have scanned him. You have done reverse, you have scanned him. And once you produce, they take all this scene, capture in a high-end camera, and they then use graphics so that it will become more realistic. So you might have seen movies like Lord of Rings or such great big movies where war scenes are very big. For example, you see our Bahubali also, we liked it because the war scene is unimaginable to be done in a regular way. But you can use 3D printing for making all those things and produce it. So that's what 3D printing helps in innovative. Like all these movies, like what you call movies, you can see Iron Man. All these suits are completely made using FDM i3 printer. On this, they coat, it appears like a metal type of printing process, right? Similarly, the Zero Dark 30, in that movie, they have to go for killing the Osama bin Laden. So that Navy camera, that is called the goggles, night vision goggles. Actually, this movie, people want to buy it original. It costs around 60,000 rupees. Then simply they scanned the original one and they produced a what you call replica of that. So that was used, and it's a very popular one in that movie, right? So similarly, hobby trials, in all these applications, you can make using 3D printing. You can make these wonderful objects which are unimaginable to make. In food processing industry also, you can see, I hope we are approaching the lunch session, but you are all now maybe very hungry, but I'll show with how you can use 3D printing for food processing, especially, for example, in this pandemic period, you don't want to go outside and eat different foods. So what you can do is you have a 3D printer, you can make your own shape of the food. Like, thing is, you can have your own pastries, you can have only pizza. Actually, NASA is now planning to send 3D printer to Mars because they are now having a mission where 2 astronauts, as I shown, will be sent to Mars for collecting all the information. But for 2 to 3 years, their expedition, their mission will be there. So when you have 2 to 3 years, they have to eat. So how to eat? In how to eat, that one is they are developing powder form, the material, all the food they are developing in the powder form, and they are sending a 3D printer along with the. They are given order to a company. They are sending this 3D printer along with the astronauts. So they produce whatever they want. They will produce using that powder, and using 3D print technology, they produce the food items which they can eat. So what is the popular technology in food printing is binder jetting, material jetting, and indirect mold. All this technology are used now. So these are the benefits. You can have your own customized food. Nutrition, for example, someone is having vitamin D deficiency in your food, you can incorporate more of that and make a customized food using 3D print technology. But remember, it is economy only at low volume production, not for high volume production, right? So with the present technology available, you can go for only low volume production. But challenges is you should have a shape stability of the material that you are using, replicate traditional foods, and real, that means flow should be good because you are using an extrusion method like wire, so the flow should be good. And also other challenging task is the safety, cleanliness of the surfaces, cartridges which are using 3D printing, because you should have that, otherwise it will affect the person who is eating that. So throughput and speed, these things you should take care when you develop a 3D printer for food processing. Right. So NASA is given order to this system and metal research company for producing this 3D printer which can be used in space. You can see this one. So you require stocks of non-perishable food. So you have to get this in the form of nozzles. So you cannot take regular food. So you have to take this food in the form of powder. They store in the form of powder, and then they can produce using 3D printing. They can produce the required pizza or burger, anything. It's a project of $125,000 project, which is used for producing these parts. So this is how 3D printing for for your food industry. Jewelry industry also embrace this technology a lot. Now you are getting very innovative jewelry, which is very difficult to produce in conventional method. Conventional CNC cannot produce complex designs, but using 3D printing, you can produce these complex designs. So now there are two methods in which you can go for 3D printing for jewelry application, either by going investment casting or direct printing. So in investment casting method, you develop the pattern of your jewelry using 3D print technology, because complex one. Once you like conventional method, you put this mold and dip in a slurry, and this pattern is made of with wax. Wax 3D printers are available now. You make this pattern using wax and you dip in a slurry until you get the required thickness of the shell. Then you burn out, the wax will go away. In that you pour the liquid gold, and you get the required shape. This is what happens in a conventional. Most of the people are outside are using this technology, but thing is the accuracy is not as good as the direct jewelry printing process, but it is less costlier when compared to the direct producing the jewelry using SLM or other technology like DMLS. So these are the investment casting. There is a popular technologies used like SLA, DLP. These technologies are used for making the jewelries. So you can see this type of jewelry produced direct light processing technology, and you can see you can see the parts from the tree-like structure. So they're all like rings. You have to remove once you finish it. So in direct printing, you can use DMLS technology, direct metal laser sinter selective laser melting. Using a powder bed fusion technology, the powder gold in the form of powder, you can produce the parts. Like such wonderful parts you can produce, very intricate to make using conventional method. So these are the popular printers used in jewelry making, and these are the popular softwares which are used, Rhinoceros and Jewel CAD, etc. The advantage are customization, enable to achieve complex shapes and reduce the production time. This is one. But there are some limitations, like you have SLA, the minimal detail you can go is up to 0.1 mm and minimum future says 0.1 mm, and DMLS is 1 mm and 1 to 3 mm. So these are some burnout remnants, or these are some disadvantages, limitations, but they are slowly overcome by this technology. Right, you can use AM in electronic industry also. As said, because I was taking this subject, I was offering open elective with my electron to other branches. So I have done a project with electronic students also, where we have developed this horn antenna using 3D print technology. So horn antenna is used a lot in communication electronic industry. We used a SketchUp software for developing this horn antenna. So I got the chance of guiding electronic guys also. So that's how 3D printing helped me in going for multidisciplinary or interdisciplinary approaches. So I started working with electronic students, and we both developed the horn antenna using this 3D print technology. So we produced that using our FDM printer, and this is now you can coat a conductive metal on it, and you can use it as antenna. Conventionally, they are using a sheet metal for making antenna in electronic communication process. Now, instead of that, this 3D printing, we are able to make very good surfaces, and on this we are coating. The amount of signal loss is very less. So we use coating using a conductive paint like the XTC 3D to improve the signal transmission. So then we have sprayed silver, copper spray, also shield painting, we have done it. So in electronic industry, popular 3D print technology is used is two technologies are there, inkjet and aerosol, but popular technology, aerosol technology. Inkjet is, if the nozzle get clogged, the droplets will not come out. That is the problem, like your inkjet printer. Aerosol technology, it is very easy. It has clog resistant nozzle, etc. You can produce direct all parts of a cell phone using 3D print technology. So print me a phone is a very interesting concept. You can see The Economist. Every part of this phone is printed, developed using 3D print technology. And like Nokia developed its phone called Morph. Like this, different applications of electronic, you can use 3D printing. So it's becoming popular in electronic applications also. So we can use in construction industry also. 3D printing can be used in construction industry. We have made a model of the Usman University Arts College, the iconic model using our 3D print technology. So before you develop, you build any product, before you build any big huge structure, to have an idea how that structure looks after it made, you can have a 3D model. Instead of seeing the 2D drawings on the screen, you can develop the 3D model. As well as now people in China, I hope all of you know, in pandemic they produced a 3 to 4 story hospital within 10 days. So using 3 big printers like this, using that they produce 3D print technology. Actually, in El Salvador, the African country, they produce one complete colony using 3D print technology. One company called Tech Inside, they produce this entire house using 3D print technology. So this how you are. So we have produced this. This is how we have done this. So we have collected the data of our OU Arts College building. All the photos we have collected. Then we developed the CAD model using CATIA software, converted into a STL file, then produced the model in 3 parts. So we have taken all the images of our Arts College, even the Google photographs we have taken. Because no one has got the original drawings of that Arts College, which was done 100 years back. So we have taken complete. Actually, if you can go use a drone and collect the information using photogrammetry method, you can do it more exactly. But at that time, this is done for 4 to 5 years back. I worked with civil engineering students. We had this project. I guided civil engineering students in developing this model, and civil and mechanical guys both worked here in this project. And the civil guys went with the survey material, get all the details from that model. Even we done with for our engineering college also, we have surveyed and got all the data of that our building. Then our mechanical students, they are good in CATIA, so they developed these drawings of all these things. So we made this in 3 model, 1, 2nd, and 3rd, and then we joined using a glue all this one. So we got the final model. Using this small printer, we can do such wonders. So we have made this and modeled and produced. It was taking around it was taking around 7 hours 5 minutes for making each side of the 3 blocks. And we produced it and joined it. We made the entire model. Actually, we made a memento of this one, right? So finally, this what I can say. 3D printing can be used in interior design also. You can use it. Like imagine you want to put such kind of thing, because now interiors are becoming very popular in any house, because you don't want to have a house with bare walls. You'll want to have something aesthetic sense into that. So you can produce using this 3D print technology. Yeah. So you can see all the models using 3D. So future of AM is, you think about 4D printing now coming up. The 4th dimension is what you call it as the either a external stimuli like a chemical reaction or a time or a temperature, etc., which will make a 2D object into a 3D model. This is done in MIT. You can imagine this is the 2D model which is kept in a liquid, and it starts, because of the reaction, it starts building into a 4D model, into a 3D model. So 2D converting to 3D model. The 4th dimension is your chemical reaction, also time dependent. So I conclude. I thank my director Venkatesh and Kumar, principal and head, for allowing me to do this research work. I also thank my students who worked along with me doing this, and I also thank the doctors who are there in carrying out this work. So you have any queries, you can ask. My contact. Thank you all.
Thank you, sir. Now I request the participants to post in any queries they have with reference to the talk.
Any questions, sir?
You can type in the chat box.
Am I on time or I've crossed my time limit, sir?
No, sir, it's all right. It's correct. You maintain the pace.
Yeah, that's why a little bit I'm going fast. I don't know how far I reached you. I hope before lunch they may be hungry and angry, but I made myself know how to make within 45 minutes because speaking for 2 hours easy, but reducing the time is something challenge for any teacher, I think.
So
So
there is one query, sir,
yeah.
from Rakesh. Which particular material can give same performance after recycling? With reference to 3D printing materials.
Oh, 3D, same performance. Okay, that's a good question. So performance wise, what you do is you will not, again, when you reuse it, you will not directly use the entire unused powder. You mix it with the new powder, which is like 60. For example, I am using a powder bed fusion technology. I go for 60-40 percentage, like 60% new powder, 40 percentage old powder. The question is depending on your application, you definitely the reused powder will not have that much of strength like a new powder, but definitely it will satisfy your application. For that application you don't require that much of what you call strength. It will work for you, so you can go for reused powder, but some application doesn't allow for reused powder, so again I have to go for fresh powder. But any powder, the reused one will not have exact strength, similar strength like the original one. It definitely, because when you are exposing your powder bed fusion technology, when the powder gets exposed to laser, the powder which is nearer to that original powder will also get exposed to some temperature changes, right? So it will have some change in its chemical properties, so it will not be exactly same. But by taking the correct proportion of mixing the used unused powder, you can get a good mechanical properties which will satisfy your requirements.
There is one more query from Koteswari. In
We can get
metal
mirror.
printing, can we get mirror finish, which can be used in medical instrumentation?
Yeah, that's a thing is in metal printing, what happened is the nowadays, for example, you talk, we are having SLM technology and other things. So where you got 99.9%, the density will be good. It will be as good as the conventional process, but definitely it is not like CNC machining. What are the finish you get? You will not get exactly from the printer, but you have to do some post processing. Earlier, for example, you take the other processes in earlier process like in SLS or other things like polymer based technologies. What happened is there is a porosity is there which is affecting the final product, so you will not get that much. Even SLS has got good surface finish, but when compared to the metal SLM etc., SLM has got higher surface finish. It may be in the micron levels, but nowadays they are using for implants. It's suitable to the implant. You can directly use that part which is produced using SLM or other DLP, or you can call DMP technology, direct metal printing. They can use, but only thing is when you try to separate that part from the bed, which is the part is made of metal, no, it will adhere to the, it will, so there you have to do either remove separation. When you do separation, no, definitely you get some kind of projection, so that you have to remove using a finishing, like you can do you can separate the parent part from the bed through EDM technology, or once you remove it, then you have to do some post processing to make it look better. You are getting surface in micron levels in using the SLM or DMLS technology. You are getting such better surface finish also. Definitely you have to go for post processing. Either you have to go for higher surface finish, you have to go again post processing, which would be a suggestible for resin molds. So you can go for SLA technology or polyjet. Polyjet is giving more accuracy. SLA, okay, SLA also you can use it. You can use for that molds, you can use for SLA. Nowadays we got SLA DLP also. But most popular technology either SLA or depending on more accuracy, you can go for polyjet also. Both are resin-based technologies.
I think there are no more queries, sir.
Thank you, sir. Any questions? They can mail to me also. No issue.
So on behalf of everyone here today, I thank Dr. L. Sivaram Krishna sir for taking the time to deliver the keynote talk on very important topic of 3D printing. Your presentation on case studies of application of 3D printing in biomedical, aerospace, sports, and other areas are really interesting. I hope this will certainly enthuse participants to take up further research in these areas. Once again, on behalf of Mechanical Engineering Department and Vienna VGIT, I thank you, sir.
Thank you very much, sir, for the opportunity given. I
Uh,
also
sir,
thank
thank you, sir.
Chenakeshwara, sir, director,
Thank you.
for
Thank
your
you.
support, sir. Thank you, sir.
Yes,
Nice
sir.
to see you, sir.
Yeah, nice
Thank
to
you,
see.
sir. Thank you, sir.
Yeah, thank you for sparing your time, valuable time.
Thank you,
in
sir.
this wonderful lecture.
Sir.
So thank you.
Thank you, sir. Thank you.
What is the next program, Shivraj?
Sir, we have already shared the links with the participants for the technical session, sir. So it will start at 2 o'clock. Yeah, parallel sessions would be running.
Okay. Go ahead. Okay. Thank you.
Thank you, sir. Thank you.
Thank you.
Sivaram Krishna garu, thank you very much, sir.
Thank you, sir. Thank you, sir. Gupta, sir.
Thank you, sir.
Thank you,
Down,
sir.
sir. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you very much, sir. I am leaving, sir. Right.
Yes, sir. Yes, sir.
Thank you.
2
Right,
o'clock, you can join, sir.
2 o'clock, sir.
Yes.
Now it is 2.
Maybe
Now 5 to 2.
Another 5 minutes.
Only 5 minutes. You are not giving for lunch break. You are not giving any lunch break.
Yeah, go for lunch. I think
yes, sir. You can take lunch and come back, sir.
Yeah, right. Thank you, sir. Thank you, sir. Thank you.
Sir, sir, good afternoon.
Yes.
Shall we join with that link, session link?
Yes, session link. It won't be here. Now you need to join in the technical session links.
Okay, thank you so much, sir.
Thank you.